Ladies and gentlemen, dear jury members, dear young scientists, welcome, bienvenue, welcome zu der 51. Edition vom Concours Jonk Fuerscher.
Welcome to 43 national teams from 15 different schools and universities. Welcome to all parents, friends, and former Jonk Fuerscher who have come to support our young scientists. Welcome to partners and sponsors. And finally, big welcome to the friends of Fondation Jeune Scientifique.
Fondation Jeune Scientifique Luxembourg is a non-profit organization with the aim to promote scientific culture among young people between 11 and 21 years old. My name is Natalia. I currently work for the Intellectual Property Institute of Luxembourg, but I also used to work for the foundation. And it's my pleasure to be your host today and tomorrow together with Marie.
My name is Marie, and the Jonk Fuerscher contest has had a huge impact on my life. I participated twice before with my projects in math and medicine, and the contest inspired me to pursue these subjects at university. This year, together with Natalia, we are more than happy to be the moderators of the 51st National Contest. It will be held under a hybrid form. Each team will have the opportunity to come on stage to present their projects to the members of a jury currently present here, whilst you can tune in live through different online platforms. Please also note that this coming Sunday, you can come to visit the projects in person during the open house at the forum and exchange directly with our young scientists, so please come numerously. I now have the honor to call on stage the president of the Fondation Jeune Scientifique Luxembourg, Mr. Carlo Hansen, to share his word of welcome and officially open the events.
Dear young scientists, distinguished guests, welcome to the 2022 edition of the Jonk Fuerscher contest. The greatest enemy of knowledge is not ignorance, it is the illusion of knowledge. A quote that has never sounded more powerful, a quote given to us by Stephen Hawking. We, you, your neighbor, me and everyone in this room and on our virtual platform are here to celebrate, protect, and prove that knowledge is something worth fighting for. For 51 years, young scientists have proven over and over that knowledge is not lost and that it is carried from generation to generation to further humanity. Sadly, sometimes it has been misused, brought off the path, but in the end, proper knowledge always persevered. In the times we are now, how dark they might feel, we must look to the young scientists today and see hope for a future free of illusions and lies. Today, we are here to honor those young scientists who have persevered, broadened their horizons, and succeeded in lifting the mist of illusion to find a piece of knowledge. I can only emphasize how proud I am to congratulate them, yet also caution them on their future path. With success comes responsibility. I am honored to introduce to the public the young scientists of 2022, and I'm overjoyed that so many people have joined us to show their interest and their appreciation for the efforts given by the participants of the national contest. Dear young scientists, I'm sure I speak for everyone present when I state that we are proud of you and of your achievements, and hope that these days will show that you are never alone. Life is like an adventure, and like any adventure, may they be in games, books, or movies. An adventure is only an adventure when it holds trials and tribulations. Push, shove, never give up, looking for knowledge. And now it is time to celebrate and start our 51st Jonk Fuerscher contest. I can promise you that you will be surprised, amazed, and hopefully enjoy the event. Thank you very much.
We now welcome on stage our first competitor, Mr. Czesimir Hiszik from the European School, who competes for the 4th time in a row with an informatics project. As forests need to be protected and managed in a sustainable way, forest conditions need to be constantly monitored. Therefore, Czesimir analyzed aerial images of Luxembourgish forests to aid forest management. I'm very excited to learn about how he did it. Let's hear it from him.
I'm Czesimir Hiszik from the European School. For this Jonk Fuerscher contest, I have developed a project that utilizes artificial intelligence to classify aerial tree images. Firstly, trees are an important part of the ecosystem, not only because of photosynthesis, but also because of topics such as biodiversity conservation, soil stabilization, or even provision of habitats. However, due to multiple factors such as climate change, forest fires, or other human-caused actions, the overall forest area is decreasing. This leads to loss of biodiversity. Unfortunately, this problem is also visible in the Luxembourgish forests. Firstly, I have acquired data from the government website of aerial images of the entirety of the country of Luxembourg, as well as LiDAR data. LiDAR data represents the elevation at a given point on a terrain. The first step in the development of the project was the creation of an algorithm to extract the location of individual treetops from aerial images. The algorithm uses multiple convolutions alongside millions of centroids to pinpoint the location of individual treetops on a map. The next step was the usage of a Hilbert curve when flattening a tree image. Hilbert curve preserves data locality. That means features that are close to each other on the original image will most likely be described by the same wave. Now, to increase the accuracy of the classification, I had to structure the data. To do that, I use a mathematical method called this ring Fourier transform. It's an algorithm that is able to represent an array of arbitrary data as a sum of multiple waves. The next step, in order to classify unlabeled data, I had to use an unsupervised machine learning k-mean classifier algorithm. 8 means grouped into 3 buckets have been used to classify the data. Unfortunately, the 8 means represent unique feature combinations derived from the population of Luxembourgish trees. So, the final results have been obtained through a combination of a space-filling Hilbert curve, discrete Fourier transform, and an unsupervised machine learning k-means classifier. Firstly, 92% of trees are classified as typical. The next 3% are inconclusive cases, whereas the remaining 5% are unfortunately classified as atypical and need further investigation by the foresters. Thank you very much for your attention, and I'm happy to answer your questions.
Without further ado, let us have a chat with the director of the foundation, Mrs. Susanna Young, to get a glimpse of what went into the organization of this hybrid Jonk Fuerscher contest.
Susanna, je sais que l'organisation du concours a beaucoup changé les dernières années. Est-ce que tu peux nous en dire plus?
Oui, tout à fait. Alors, tout d'abord, on est extrêmement ravis de pouvoir retrouver le format traditionnel, fort de 2 années d'innovation dans le contexte de la pandémie. On est tellement content de pouvoir à nouveau remettre l'interaction au cœur de nos plateformes, ce qui est quand même le point le plus important et le plus fort pour les jeunes, hein, vivre des expériences, rencontrer leurs copains. Et donc, si l'organisation a évolué depuis ces dernières années, c'est surtout pour ça, surtout avec le fait qu'on a dû adapter nos plateformes de manière virtuelle, de sorte à pouvoir continuer à offrir des échanges, une plateforme d'expression pour nos jeunes. Et maintenant, puisqu'on a un retour plus ou moins normal, ça a évolué dans le sens où on a gardé quand même la partie virtuelle où les jeunes viennent ici au forum présenter leurs projets un à un, en face des membres du jury, mais aussi en direct avec nos partenaires RTL, donc en direct sur le live stream RTL. Et en même temps, le dimanche, il sera possible de venir sur place, rencontrer les jeunes sur leur stand, échanger directement avec eux et découvrir leurs merveilleux projets.
Ça va, merci. Et cette année, l'expo Sciences Luxembourg et le concours ont lieu séparément. C'est quand la date pour l'expo Sciences?
Oui, tout à fait. Les événements ont pour la première fois depuis 10 ans été séparés, et ceci pour clarifier nos plateformes, puisque le concours est une compétition d'un côté, l'expo Sciences est non compétitive de l'autre. Et l'expo Sciences aura donc lieu du 6 au 9 octobre 2022.
Ça va. Et quel mot d'encouragement... Ah non, encore combien de projets ont été soumis cette année?
Alors cette année, en préinscrit, nous avons reçu 87 préinscriptions. Finalement, 63 jeunes participent cette année. Voilà.
C'est beaucoup.
Oui, c'est beaucoup.
Quel mot d'encouragement encore pour les participants cette année?
Alors, bien sûr, nous sommes dans le contexte d'une compétition, mais c'est avant tout une plateforme d'expression. Donc, je leur conseille de continuer à être curieux, créatifs, innovants, de bien s'amuser, de bien échanger avec leurs copains et leurs copines et de repartir encore plus fort, encore beaucoup plus inspirés, avec beaucoup plus de motivation pour répondre à leurs propres questions à travers des merveilleux projets scientifiques. Et je leur souhaite à tous bonne chance.
Super. Merci, Susanna.
Gros challenge, comment recevoir les jeunes nationaux sur place tout en garantissant une sécurité et comment créer de l'échange avec nos lauréats internationaux à travers des moyens virtuels. Alors aujourd'hui, on a réussi à trouver un format de congrès pour le concours où les jeunes viennent au forum pour présenter leurs projets un à un et on remplace le public par du live stream.
Also die Jury den hat de Rolle für die verschiedenen Projekte zu den verschiedenen Preisen, die die Fondation organisiert, zuzuordnen.
On a créé spécifiquement pour cet événement une plateforme virtuelle avec la planification d'activités qui permettent cet échange. Donc aujourd'hui, on est en plein dedans et on peut dire que le challenge est réussi.
Is such a great platform to encourage students to pursue their interest in science. So 2 years ago when I did the Jonk Fuerscher first, I got really interested in fractals, which are these shapes in math that are a bit rough and complex. Recently, when I was doing my course in medicine, studying neurodegenerative diseases, I got really interested in Huntington's disease and decided to use fractals to look at the DNA sequences of these kinds of diseases.
Ich finde im l'impression, dass von Jahr zu Jahr das Niveau immer mehr hoch geht.
Ich persönlich und Kreativität von den jungen Leuten gelesen und absolut überzeugt sind, dass das der Schlüssel ist, die Jungen zu unterstützen, für Lösungen zu finden, ob die großen Probleme, die uns derzeit bewegt haben, zum Teil heute auch noch bewegen und noch in der Zukunft bewegen werden.
Mon but, c'était un peu de vulgariser les articles. Très souvent, dans plusieurs revues scientifiques pour enfants, c'était soit des trucs plutôt trop faciles, et que c'était aussi des adultes qui expliquaient. Moi, je voulais que ce soit un enfant qui l'explique. Il y a, comme toujours, un peu de stress, mais vraiment, quand on est sur la scène, c'est vraiment une très bonne expérience. En plus, je trouvais que les juges étaient vraiment gentils, et c'était vraiment très intéressant d'être là.
Our next participant is from the St. George's International School, and he'll present his project called OrmCrypt, a Python code based around cryptography and the technology of encryption and decryption. But let Morgan Sarno-Pekla speak for himself.
Hello, is this working? Yeah? Okay, perfect, thank you. Hello everyone, good morning. I'm Morgan Sarno-Pekla, and today I'll be presenting my OrmCrypt project. So beautiful. Okay. So what is OrmCrypt? Well, OrmCrypt is a Python code that I wrote. It is a solo project, so I worked on this alone. It's individual. It basically is a Python code that allows you to experiment and encrypt and decrypt. So just a quick explanation of what encryption is. Encryption is basically changing a text in a way to make it unreadable to humans for security reasons and to prevent it from malicious access. So my Python project basically explores encryption and decryption, which means that you can do a bunch of functions. For example, use the encrypt function, which means you are asked to input a text, a message, anything, let's say hello, and then it encrypts it and outputs or displays the encrypted value. It uses a shift cipher, which basically means that each character that you can encrypt and decrypt is assigned with another character using a layer key. Why this project? Well, mainly because I love coding. I enjoy challenging myself with fun projects like this one. And I also wanted to explore cryptography, which I found out I loved. I think it's really interesting, and I'm very passionate about it. So basically, what is the future of OrmCrypt? So I have two main goals. I have a short-term goal and a long-term goal. My short-term goal would be to include a password manager, meaning that you can store passwords, username, and other details encrypted on your computer safely, and add another layer of encryption, which basically means right now I'm using the cipher, shift cipher, and adding another method and another layer of encryption is basically adding another layer of security and making it safer. And then my long-term goal would be to possibly create a website or application for OrmCrypt. I think that would be a very nice end project. Yeah, I think that's kind of presenting my project, and yeah, that's it.
Let us have a little exchange with Krzysztof Hysik and his motivation to participate over and over again in the contest.
Krzysztof, how did you come up with your project?
I mean, basically trees are everywhere around us, and I mean, I have seen when I was walking back from school, I have seen some trees that haven't looked the most healthiest, and basically then I have looked into it. I have downloaded the data from the government website, and I went along with the project.
Okay. And how long did it take you to finalize your project?
Generally, I mean, there were two parts to the project. The first one was the data preprocessing, and the second one was the actual implementation. The implementation part took a couple of days, however, data preprocessing took upwards of 1,000 hours. So, yeah.
And to write the project, how long did you take for that?
I mean, I do a lot of programming, so the programming part itself didn't take long. However, I would say a day or something. However, the grand majority was the like data preprocessing itself, because I used around 50 different programs written for that, and each of them did a different thing. So,
yeah. Yeah. As we can see, programming is your passion. Do you have another one? Do you have any other?
I mean, theoretically, building robotics could be considered another passion of mine. I do not pursue it as much as programming, mostly because programming is easier to do anywhere rather than building a robot. So I would say robotics.
Yeah. And do you have a last word of encouragement to the other contestants?
I mean, just basically, if you have an idea, just go for it. You will make it. Yeah, just go for it.
Yeah. Thank you very much.
But the young people are
Welcome to Max Gold from the St. George's International School, who is also a returning participant. Max pushed his project from last year further by creating a whole collection of Python programs aimed to solve chemical and mathematical equations. Please welcome Max on stage as he presents his project.
Thank you. So hi, my name is Max Gold, and this is the continuation of my project from last year on solving mathematical and chemical equations. Just to outline, the 4 new aspects of this program is a new chemical parser, 2 new mathematical programs, and a website to house all of these programs. First up, we have the chemistry bit. Last year, while I was going through my program on using matrix manipulation in reduced or echelon form to balance a chemical equation, I was looking at places to improve, because there's always somewhere to make it more efficient in a program. And the first bit I decided to change was the chemical parser. Now, a chemical parser is something that converts a chemical equation into matrix form, because obviously a computer can't just take an input and convert it into a matrix automatically. There needs to be a program to do so. Now, last year, there were a few problems that could have been improved with this parser to make it even more efficient. The first of which is that they couldn't handle multiple occurrences of the same element, such as an ethene. If you had CH3CH3, it wouldn't count the 2 C's or the 2 H's. Second of which is more than 999 of a single element. If you had, say, a C1042, for example, on a carbon, it wouldn't work because the program would only count the next 3 values in a string. And finally, it wouldn't handle nested brackets. It could only handle one-dimensional round brackets, so this would produce an error. So to get around this, I decided to create an algorithm. First of which, so this is an example of a hypothetical compound that pushes the boundaries of what the parser can do. So first of which, it checks for first-dimensional brackets, as you can see here, the outer layer square brackets, and then puts them into a dictionary and replaces them in a list with a placeholder of a tuple with its position in the dictionary, followed by a comma, just to make sure that the tuple is indicated. And then it continues to split it by brackets further on, addressing those brackets to a new position in the dictionary. As you can see here, the brackets keep splitting into their new places until it's reached what's called a base state, where there is no more brackets in any of the places in the dictionary. And this is achieved by what's called a net bracket solution. So if you have a left bracket, both square or round, that's +1 on a counter. But if you have a right bracket that's square and round, that's valued as a -1. And so when there's a net bracket of 0, then it can push that into a new location in the dictionary. So now that we have this base state dictionary, we can then split each item of base state, so the SO3 and the SO4, at every capital letter, considering every single element has at least 1 capital letter, so you can split it down there. And then per element, you can split it at the first index of an integer, so that you can have an infinite number of integers per element. And once we do that, we can then work from right to left, filling in all of the placeholders of the positions, until finally we can get this value where all of the placeholders are filled, and then element amounts like sulfur and oxygen, which have occurrences of twice, can be simply combined to make one final list. Now this, again, solves all of the problems of the previous one. So this solves the problem of multiple occurrences, infinite number of nested arrays and dimensions, and number of a particular element as well, and can be used not only for matrix manipulation, but considering you have the number of a certain element, so you have the number of the amount of certain element, you can then multiply that by an element's molar mass, combine all of them together, and make a molar mass for the compound, which can be quite useful in especially mole calculations. Now the math contents. These are 2 principles in maths, that one of which already has a formula. But to make it more efficient and to allow a wider range of inputs, I've created my own formulas to make use of these. First of which is algebraic division. This takes a dividend of a polynomial of degree n divided by a polynomial of degree 1. As you can see here, it uses simple long division that you would use regularly for regular numbers, but just replace it with variables. It comprises, and this formula the answer can be represented as a sum and initial term, as shown on this slide. The top is the initial term, the second is the sum, the third is a representation of what those variables mean, and the bottom is an example. So you can see here, A0 is the initial term, E is the degree of the dividend, M0 is the coefficient of the first term in the dividend, CS is the coefficient of the X term in the divisor, MN is the nth coefficient in the dividend, as represented in the third bit there, V is the constant in the divisor, and A, n-1 is the previous term in the series. So it's basically, it uses the previous term in the series to make the new term. Now, the next bit is binomial. Binomial already has a formula. As you can see, sum from k equals 1 to n of n choose k, x to the n minus k, y to the k. And that is a binomial. But the problem with this is that obviously in the n choose k there's a factorial, which as n and k tend to get bigger, those factorials become increasingly difficult to compute. So I made one that would be easier without any factorials, but instead multiplication. As well, the top formula only has an input of positive integers, whereas the one I've created allows for negative inputs and fractions. Expands binomials are very important for distributions and polynomials. C is the constant before the binomials, such as 2 in the 2 in 1 plus x to the half. C0 to the n is the constant C0 raised to the power of n. And m is either the limit chosen by the user of how many coefficients they desire. If s is a fraction or negative, this is because if s is a fraction or negative, the sum would be infinite. So for the user, they could choose how many places they want. Otherwise, it's s plus 1 if s is a positive integer. And I decided, in order to house all of these programs for other students to use, I created a website called GoVac. It's built using Flask, which is a Python library, which means the Python programs can interact. What, sorry? What, sorry? Oh, OK, of course. It's last slide. Built using Flask, it's a Python library to allow seamless interaction between the programs. It's used on Google Cloud Run, so it has the reliability and safety of Google. It stores all of the programs, all of the ones from last year, including the maths ones this year. It allows users to store their equations. So if you input it either by the URL or on the website itself, it will store them if you log in, and then you can access them at any time. And the URL is www.govac.eu if anyone wants to try it out. Thank you very much for watching.
Let's hear Morgan answer some questions about his project and have him reveal his thoughts on science and research.
Morgan, thank you for joining me. Is this the first time that you're taking part in this contest?
Yes, this is a very exciting first year.
Yeah. Your project is called Ormcrypt Encryption Decryption Program. How did you come up with this project?
How did I come up with the name or the project?
Both.
Okay. So my name is Morgan, and I took the 3 first letters and scrambled them because that's kind of what encryption is about. You know, scrambling things and creating gibberish. So it became Ormcrypt, which was pretty funny. And how did I come up with the project? I just really enjoy coding and wanted to challenge myself. And we were learning about encryption in class, but not how it works really, just more about why it's used, which was already interesting, and decided why not make a Python program that does it.
Yeah. And how was the experience for you on stage today?
Fun. It was very fun. I enjoyed it a lot. I think, yeah, it was very cool.
And with the jury afterwards, did you have many questions from the jury?
Yes, many about how I'm going to improve it and changes I'm planning to make, because hopefully I'm coming back next year with an even more developed project. So, yeah.
On the same topic, or?
Yes, mainly on encryption, and yeah, I'm planning on adding some new features and a password manager, but yes.
Okay.
Can you develop on the progresses you want to make?
Sorry?
The improvements you would like to make, can you develop a bit about it?
Yeah, of course, sure. So I'd like to add more layers of security. So right now I'm using one layered cipher, which means it's just using one way of encrypting. And if I add several, then it's going to be more secure and harder to decrypt. And I'd also like to add a password manager, which means, you know, save logins and emails and usernames and things like that safely on your computer. I think those are the 2 main goals for now. Okay. Yeah.
Well, have you heard of Bletchley Park, which is the decryption place in the UK during the Second World War?
Oh,
no. So
no.
your program wouldn't be able to crack code of secret code.
I mean, it would be an extremely fun idea to try.
Application,
Yeah,
yeah.
sure. I mean, it sounds very, very fun. Yeah.
And tell us more about what motivates you to do science or to do this kind of research and deepening your understanding.
I think it's mainly I just like being able to create something that functions and works out of a blank piece of paper and making it, being able to interact with it, and something really just that you created from nothing is super, super, super rewarding, and it's just a really cool experience, I think, in my opinion.
Okay.
Yeah.
And when did you start off conceiving the idea for this project? Was that during the last school year, or?
It was about a year ago, yes, a year and a couple months ago that I had the idea first, yeah.
And who supported you in the project?
My parents and also my computer science teacher. I showed her right off the bat the really, really garbage first versions of it, and she always supported me and my parents as well, so.
Okay. When did you do the final touches on your report for the contest?
For the contest, 2-3 weeks ago, maybe a month ago, just making sure everything was good and working, yeah.
And did it take you a lot of time next to your other schoolwork and responsibilities? How did you? What was it like to juggle lots of different?
It was fine because I enjoy it so much that it's not really, it doesn't feel like work when you're doing something that you enjoy a lot. So it was fine. Sometimes I didn't have as much time, sometimes I had more time, but overall it was fine. Yeah.
What questions would you like the jury to have asked you at the end of your presentation?
Oof. What question?
Or sort of, what did you run out of time giving your presentation? What things did you have to cut back on that you would have liked to talk about more?
I think I should have shown maybe an example or more detailed presentation. My presentation could have been a bit more detailed, in my opinion. And that could have answered some questions that the judges had, which would have been useful. But, yeah.
Well done.
Thank you.
Thank you very much.
Thank you.
Yeah, we have a goodie bag.
Cool.
Yeah, you had a lot more.
Lined up next, we have Bartlomiej Novak, enrolled at the European School 1, with his project on an artificial neural network with which he generated a model of CO2 emissions and simulated different economic scenarios.
Welcome everyone, I'm Bartlomiej Novak, and today I would like to present you my project about the use of artificial neural networks for predicting carbon dioxide emissions based on economic data. Artificial neural networks are a great tool for data analysis. They can detect trends and patterns which humans often struggle to see, helping us better understand the research problem. I've utilized these properties of a neural network to predict carbon dioxide emissions. I later use the trained model to measure the impact of specific economic metrics on carbon dioxide emissions. So let's talk a bit about these economic metrics, because data is a key part of any machine learning algorithm. It has to be accurate and relevant to the research problem. This is why I used economic data, because economic activity often involves polluting processes. So we can expect there to be a relationship between the intensity of economic activity and carbon dioxide emissions. The specific economic metrics used in the project were global coal production, global oil production, global population, global gross domestic product, total industrial production in Europe, and total driving distance in the United States of America. Unfortunately, we cannot just use the raw data sets which we download from the internet or other sources. It doesn't contain unnecessary information, which would actually decrease network performance. This is why it's necessary to clean the data. In other words, remove all of these unnecessary elements. Here we can see an example of this. On the left, we can see a raw United Nations population data set, and on the right is the simplified data set with only the necessary information left. It is much simpler, but the network should perform better at lower computational cost. It's not the final part of the data processing chapter. We also have to normalize the values, because neural networks don't perform very well with very large input values, which you might get with economic data. This is why it's necessary to scale the data to a range of 0 to 1 with the use of linear scaling. This should increase network performance. So let's talk a bit about the neural network, the brain of this project, and the structure which actually translates economic values into carbon dioxide emissions. The predictions are made in objects called neurons, which make calculations on the input value. After the data is passed through the whole neural network, so from the first layer to the last layer, the final prediction is made. Unfortunately, at first, the predictions are completely random, resulting in a very high loss. This can be seen at the start of this loss graph. And loss, in simple terms, describes how wrong the model is, how far away is the prediction from the true value. Thankfully, over time, as can be seen, the loss decreased. So the predictions were better and better over time. This is thanks to the gradient descent algorithm. The gradient descent algorithm could be thought of as going down a hill. Just in this case, the hill is the graph of the loss functions. So you're making these very small changes in the model, in the ways inside the model, to push the output value a bit closer to the real one. We repeat this process many times until we eventually reach a local or global minimum of the loss function. After a full training process, the network performed very well, as can be seen by how closely matching the predicted emissions and the real emissions are. This can be seen as a proof of the ability of a neural network to correctly analyze and interpret data, and shows the relationship between economic activity and carbon dioxide emissions. However, we can make an even deeper analysis using the model. We can measure the impact of specific economic metrics on carbon dioxide emissions. Here we can see the predicted change in emissions with a decrease and increase in oil production. Here's the same analysis for coal production. As can be seen, coal production is deemed a more significant factor for predicting carbon dioxide emissions, and generally is more influential in their value by the more drastic decrease in carbon dioxide emissions with a decrease in coal production. To conclude, I successfully applied an artificial neural network in the analysis of carbon dioxide emissions. I later used the completed model to measure the impact of specific economic metrics. This analysis deemed coal as the most influential factor. Such information can be used by governments and policymakers to make more effective policies and decisions to tackle the climate change crisis and the pollution crisis. Thank you for listening.
Please welcome back Max Gold for a short interview to hear more about his experience as a Jonk Fuerscher so far.
Max, you were presenting your project again this year after having developed it further. Tell us a bit more about what you found out this time.
Well, going over the project from last year, I was looking at ways to improve it, make it more efficient, make it overall, allow more inputs in a more, make it more reliable. And so looking at that, I saw some flaws in this in the chemical parser, something that converts an equation into a matrix. And there were obviously some flaws in that, about the number of elements it could handle. Brackets was the main thing. And instead I developed an algorithm to solve all these problems using what's called a Python dictionary. And then after that, I decided to transition to maths programs as well. So now it's no longer just chemistry, it's maths as well. And it's basically those two are redesigning formulas to compute certain principles that we learn in IGCSE and AS maths to allow them to help students to check their answers and just understand how the principles work. And then all of these are now housed on a website that I've created, which is built using Python as well. So it allows for those programs to interact seamlessly, which is really neat. And then all of these programs are stored on there, so everyone is able to use them. It's on the internet. And then if you input an equation, it will store it for you if you log in, and you can go back and look at that equation anytime, which I thought would be really useful for students. So.
Yeah. How many logged in registered users do you have?
At the moment, I don't know. I haven't checked the data yet, but hopefully as I advertise it more through this competition as well as through other platforms, hopefully that number will start to grow.
Yeah.
Yeah.
Yeah. And
I have a small question here. You actually participated last year, so it means on the same project, but you've been developing it. Like, would you say that the experience helped you, or did the new topic propose some new challenges that made it even harder this year for you with mathematics?
Yeah, definitely the maths was a new challenge. It was something different from last year, obviously, with the chemistry, and moving on to a new subject was an interesting challenge to take on. But also I found the chemistry bit to be the most difficult because it was I'd already made it, but I had to improve it, and because it was it was a very difficult algorithm to create, because I'd made the previous one as sort of it fits some of the ones that I put in, but not some of the equations that I put in, but not all. So trying to find a way to permit all equations to be put in was one that I found really difficult, but in the end it worked out for the better, so that was good.
Okay.
do you have any ideas for developing it even further after this?
Definitely. After studying AS chemistry for a year now, I've learned some new subject areas, such as organic chemistry is one of the big ones, but also one of the most difficult.
I guess.
Yeah, definitely. So yeah, all my classmates and myself included find that the most challenging of the course this year. So if I were to create a program to handle one to input organic compounds, and then do equations and reactions, because the main thing with organic chemistry is there's a lot of reactions to remember. So if I allowed a user to input an equation or a compound in itself and then say, oh, I want to do this particular reaction, it'll then give the output. And I think that would be really useful, not only for me to remember all the equations, but to help other students just learn and practice through that, I think is a big thing for me. So.
Was last year the first time that you took part in the contest?
Yes, last year was the first time I took part in
And
competition.
what happened what was it like last year, and what prize did you win? Where did you go?
So last year, also, could you repeat the question?
What did you win?
Oh, yes.
And how it happened, because it was a really specific context,
yes,
right?
Yeah. Last year, I won the competition to go to Taiwan, the Taiwan International Science Fair. Unfortunately, that had to go online, but I still competed in it anyway, and it went well. I didn't win there, but it was a really enjoyable experience to meet people from all around the world. And also, the Jonk Fuerscher invited me to the Dubai International as well, but unfortunately, Luxembourg had to pull out of that due to COVID reasons. But yeah,
it's going to change this year.
Hopefully, yeah.
Please.
Yeah. Do you have a last word for other contestants this year?
Good luck, I guess. I guess for us all, it's not I guess it's a competition, but we all, I guess, strive to do our best. So all I can say is good luck to the other contestants, and I hope you do well.
Yeah. And what would you say to people who are willing to participate next year?
It's a great opportunity. It's really fun. You get to meet a lot of new people, and the prizes you win are excellent. They allow you to sometimes go all around the world and meet new people from other countries and cultures, and I think that's a really good aspect of the Jonk Fuerscher competition.
Okay,
Thank you
Max.
very much.
Thank you. Yeah.
Welcome to Pierre Roth from the Lycée Michel Rodange, who built and programmed a Raspberry Pi-powered machine that can solve the Rubik's Cube. Cubing is a hobby for Pierre. He was always curious to see how fast a Rubik's Cube could be solved. He participated in different cubing competitions and has been officially ranked the 16th fastest Rubik's Cube solver in Luxembourg. Welcome, Pierre.
Hello, so my name is Pierre Roth, and as they already said, I basically built and programmed the machine from scratch to solve the Rubik's Cube. And you might be asking yourselves, how do you come up with such an idea? And as they already said, I participated in some cubing competitions, and it all started when my mathematics teacher from 3 years ago brought Rubik's Cubes to class on the last lesson before the holidays. So there you can see me trying to solve what looks like a 7x7 Rubik's Cube, and my mathematics teacher surveying the solve. This is what the contraption was supposed to look like very early in the beginning. Those were just some sketches that I drew up. And as you can see, there are some similarities, but the design has changed quite radically. Moving on to how the machine was built. The machine is built out of these sturdy aluminum extrusion profiles, 30 by 30 millimeter, and here is how the frame looked when it was first being assembled. One other important aspect that needed to be addressed is how do you even connect the motors to such a cube? And because I used to clean my cubes regularly, I knew how they were built on the inside. And that's when I also knew that I could pop the center caps off, like on this Rubik's Cube, and it would show these perfect places to connect to the cube. That's when I designed and 3D printed a piece that would fit inside the cube, just like shown here, so that the cube, each individual side of the cube could be turned without being in the way of the other sides turning. Here is a picture of when it was first being provisionally assembled using zip ties. So building these motor fixtures that allow for the motors to be slid out of the cube and back in to allow for the cube to be removed were probably the hardest part about the whole contraption. And I won't go into further detail, but here are some pictures of when they were being built. Next we get to the electronics. The motors obviously need to turn the sides very precisely, 90 degrees in 90 degrees, and the position needs to be known at all times. That's why I decided to use stepper motors, just like the ones that I used on 3D printers, and some standard drivers, and as they already announced, the whole contraption is controlled by a Raspberry Pi. This is what the electronics look like. And you might be thinking to yourselves, damn, that looks ugly. But that's what I thought too. And that's why I designed a custom printed circuit board. But this is only the schematic, and all the green things, those are wires. And when I tried to auto-route the copper traces, the freeware that I used wouldn't let me do it. So I just decided to stick to the breadboard design instead. Finally, we get to the software, which is probably the most complex part about the whole contraption. A standard Rubik's Cube like this one has 43 quintillion possible permutations, just this little thing. This number is hard to wrap your head around, so you can imagine that it's quite difficult to solve it even with modern-day computers. From every given position of the cube, you can make 18 different moves. So you can imagine that as you have 6 sides, the cube has 6 sides, and each side can be turned either 90 degrees clockwise, 90 degrees counterclockwise, or half turn. So if you go further down that tree, you would eventually find the solution. Now it would be interesting to know how far do you have to go down that tree to find the solution. For instance, that's the same thing as asking, what's the maximum number of moves that I need to solve every given cube? And that's known to be 20 for the 3x3 Rubik's Cube and is referred to as God's number. And as you can probably see by what you're not seeing already, the third layer is already quite difficult to recognize what is happening. And if I extended that tree downwards to a depth of 20, yeah, I think there would be too many possibilities. And that's why it's not even feasible for the modern computers nowadays. So that's why I decided to use Kosiamba's algorithm. The algorithm, instead of trying to solve the cube directly, it divides the solution process into 2 steps that are far easier to solve. And it involves quite some group theory, which is far too complex to go into right now. But in essence, it uses under the hood, it uses another algorithm called iterative deepening A star. And that's just a fancy way of saying, instead of going down the tree blindly, it has a pre-computed memory-based lookup table, and it tries to look for the solution where it thinks the solution is more likely to be. And also, the program is able to cut parts of this tree off where it knows that the solution will not be found first. 1 more minute, okay. Here is a short a picture of what the graphical user interface looks like. It features a touch screen. And I also learned quite a lot about 3D printing, and there are a lot of 3D printed parts in this thing, but because of time constraints, I won't go into that. So now get to the fun part, the testing results. I used official, or pseudo-official World Cubing Association scrambles to scramble the cubes, and the machine was able to solve the cubes in an average of 4.4 seconds with the graphical user interface and 2.9 without the graphical user interface. And here is a short video demonstration. Yeah, so there you go. A lot of improvements could be made, like faster motors, faster drivers, faster everything, but most of them are costly, and I won't go into that further right now. And thank you for your attention.
Okay, let's get to know Bartolomew a little better now, before we have a quick break.
Thank you for joining us here. Please tell us a bit more about what motivates you to do science.
Well, I find science interesting, especially with data science, how we can use data, all the information that we have, to make a bit more informed decisions and as such more effective decisions to tackle ongoing problems.
You've been hitting 2 topics that are pretty trendy this year, like environmental issues, sorry about that, and AI. You're coming to those topics with a fresh eye. Like, what did you discover on your journey about like studying those things?
Well, I found which activities do have the most impact on carbon dioxide emissions in the case of my project. So it does lead to maybe more how we can change our lives also, and generally the whole society. How should it work to be a bit more friendly to the environment, which of course is, as you said, an ongoing problem.
And would you say that when you start on such a topic, on such topics, I mean, like the resources for you to advance on your project are easy to find nowadays, or is it still fresh and you need to put a lot of work to actually develop your project?
Well, if the access to data and accurate data is easy, then I think the improvements could be made quite easily, although it all depends on the statistical agencies. which, of course, I cannot influence them.
Of course.
So tell us a bit more about how you came up with this project. When did you first think of it? How did you choose artificial neural network as the modeling as the model?
Yeah. So I generally became interested in computer science in general because of them, and I found it really interesting how a computer can interpret data in such a way to predict values which a human would very struggle. Like you have these frankly random numbers, and how can you relate them to carbon dioxide emissions? Like human would struggle to find this relationship, and I've just found it fascinating, really, how a computer can interpret it, and as I said in the presentation, translate it, because it is a translation, really. It's just a numerical one, not alphabetical one.
From raw data to seeing patterns.
Yeah, I just find it fascinating. Yeah. It's yeah.
Some people find that a bit scary because, like they say, it's kind of a black box, and then you put something at the entrance, you look what's coming out, and you don't know exactly what's happening in the middle. How do you see that actually, even though it's working in the end?
It's interesting. Of course, you know why, like how the model learns per se, but you don't really know why it does the thing it does. So, of course, I agree. It is a slight black box. Although I think it will have a positive impact, certainly. And so we shouldn't be scared of artificial intelligence, although we have to use it wisely.
Okay.
How often did you run the model?
Oh, so yeah, in the research phase, I would say, I tried many variations of the model structure. So it's difficult to say, but at least 10 times, 20 times, to just find which combination gives the most accurate results.
Do you have any other hobbies or passion, or that are not specifically related to AI?
Oh, of course.
I'm glad to hear that.
Well, I like skiing, climbing, literature. I would say I'm a very open-minded person, open to new hobbies and passions. So, of course, science is very important to me, but it's not the only part of my life.
Okay, sounds very good.
Yeah. At school, what year are you in at the moment?
So it is in the European school system. It's S5, so the 5th year in the European school system. I don't have for the Luxembourgish system how it translate. So I'm now 16 years old. So.
Yeah. So it's a tiny bit too early to think about where you might want to go to university, but.
I have ideas, although not concrete decisions yet.
Yeah. To do more in the area of natural sciences or in computing?
I think computing. So yeah. They can be related to natural science, but I would say the main point of the project will be computer science and the use of computers.
Yeah.
Okay. Thanks a lot for your time.
Thank you so much. Pleasure to be here.
Welcome back to the contest, dear watchers. Our next three participants, Aryaman Arora, Andrew Gargiulo, and Anthony Vincenz, come from the Athene, and they attempted to use artificial intelligence to predict earthquakes. Earthquakes have impacted around 125 million people over the past 20 years, and many, many more throughout history, which is why this team's main goal was to be able to provide accurate predictions as far in advance as possible to be better prepared for earthquakes. Welcome on stage.
Using artificial intelligence to detect earthquakes with seismographic data. As said before, earthquakes have impacted around 125 million people over the past 20 years. Every lost life to an earthquake can simply be avoided with the correct knowledge in advance. That is why our main goal in this project is to provide accurate predictions to when an earthquake can hit as far in advance as possible. Artificial intelligence is the next step in the field of earthquake prediction and analysis of trends over time. This research project attempts to utilize noise data to predict laboratory earthquakes. The data set we are using to get seismographic data is from Los Alamos National Laboratory in California. The laboratory experiments consist of 2 gauge layers which are sheared simultaneously while being subjected to a constant normal load in between and a prescribed shear velocity pushing inwards. This generally represents a convergent tectonic movement. The laboratory faults fail in repetitive cycles of stick and slip that is meant to mimic the cycle of loading and failure on tectonic faults. While the experiment is considerably simpler than a fault in Earth, it shares many of the same characteristics, physical characteristics. The seismic data is recorded using a piezo ceramic sensor, which outputs a voltage upon deformation by incoming seismic waves. The seismic data of the input is in this recorded voltage is in integers. The data file has 2 separate columns. One represents the acoustic data that has been recorded, and the other, the time to the next earthquake, denoted as time to failure.
Very simply, a neural network is a type of function which can convert one kind of variable into another kind of variable. So an example would be a picture of a cat would be converted into a prediction of what this image really is. So for our model, we had to use an LSTM architecture for our neural network, as in a typical recurrent neural network, we would have to deal with the vanishing gradient problem. So this problem is created because over iterations, the weight would be multiplied by itself over and over again. So if we had an original variable x and we multiplied it by the weight w over and over again, it would tend to infinity if the weight is greater than 1. So our algorithm has several key steps. So after loading the data, we generate the batches and standardize the data. So this is the pre-processing phase. After running, all the scores are calculated by the mean average error, which we would calculate by seeing how close our model was to the actual time the earthquake occurred. So each model, or each earthquake in our model is represented by 150,000 rows at 4 megahertz, which is how the instrument in the experiment was used to calculate. And this would represent an earthquake every 0.0375 seconds. So our results would really represent how much we were off. So one thing that we really had to avoid was the overanalysis of data. So we really didn't want to overanalyze the data, meaning that our AI would memorize the actual data set rather than learning how to deal or predict. So to avoid this, we created a methodology, and this would be where we would test different batch sizes, different neurons, or the different numbers of neurons, and different epoch amounts. So generally, the point was to see and make sure that our accuracy was as high as possible. And at the very end, our model reached an accuracy of 98% mean average error, or mean average accuracy, meaning that in real life, when we converted from the megahertz, we would be approximately 14 hours off an earthquake prediction. So for the experiments, as we can see with the epoch sizes, there's a huge increase in accuracy when we move from 10 to 50 to 100. And when we compare the batch sizes, it didn't really seem to matter as much. So we maintained the 1, which has the highest accuracy. And then finally, with the neurons, the difference between 4 and 6 does not seem to be enough to in exchange for the higher amount of computational power it would have been required to run the AI.
Generally, on average, the earthquakes all share similar acoustic averages before earthquakes actually happen. This is, however, different in real life because of the different seismographic trends, different locations, and also different geological materials. We have to also consider the density of the lithosphere in the ground that could adjust the readings. For our project, we use one source of data that contained 4,096 earthquakes. The next step is to convert the actual seismographic data into simple numerical values, which is achievable and has been done before. Our model is extremely flexible and adaptable. We're able to adapt our code to the 3 different tectonic plates and keep the LSTM model. Right now, as mentioned before, we have a 98% accuracy and are able to predict at a minimum 14.4 hours ahead of when an earthquake happens. Now imagine if we could apply that to real life, how many lives we could save. Finally, a potential expansion of the project would be to predict when different tsunamis could occur. And here are the sources we used, and we'd like to thank you all for listening to our presentation.
Remember Pierre Roff's project on the Rubik's Cube? Let's hear some more about his programming skills and motivation behind them.
Merci, dass du hier warst. Aus der Zeit die erste Kehr, dass du teilhältst an diesem Konkurs?
Ja, das ist die erste Kehr, dass ich bei Jonk Fuerscher mitmache. Ja. Leider auch die letzte Kehr, weil nächstes Jahr geht auf die Uni. Ja.
Ah, ja. Maar während deiner Präsentation hast du nicht gerade genug Zeit, vielleicht zu weisen, wie die Maschine funktioniert. Ja. Kannst du das ein bisschen mehr weisen?
Maar am Anfang schon den kleinen Video während der Präsentation gewesen. Aber am Anfang war Dolo nicht rausgegangen aus dem Video, weil ich am Anfang noch dazu so wollte, dass innen in der Maschine am Eck also eine kleine Kamera, eine Webcam montiert. Und der ist am Anfang dafür da, für die Maschine auch weiß, wie die Cube ausgeseit, wann ihn rausgeholt wird. Weil wenn ihn raushält, und es in einem Gemisch dran, dann kann die Maschine ja nicht erraten, wie ein Move sie muss machen, um dann zu lesen. Am Anfang wird die Maschine aber da mischt aus, sie mischt Kamera und dann dreht die Cube ein bisschen, dann guckt sich von allen Seiten nun. Und dann sieht sie, okay, lo weiß ich alles, lo kann ich lesen. Und dann geht los.
Okay. Ja. Du hast da dort doch alles selber gebaut. Wie hast du das gemacht?
Am Anfang, das alles so bei sich daheim zu machen, ist relativ kompliziert, weil du war schon, also ich schon ein bisschen Maschinerie gebraucht, für selbst zu machen, weil die Aluminiumstecker zu schneiden, eine Löcher zu bohren. So Maschinen habe ich normalerweise nicht daheim. Und da geht die große Merci um mein Bob und mein Peter, die mir am Anfang all die Maschinerie zur Verfügung gestellt haben, mit der ich die Projekte realisieren konnte.
Ja. Aber an welchen Stecker wirst du müssen kaufen oder organisieren von außerhalb?
So gut wie alles. Also, also die Aluminiumstangen die muss ich dann halt bestellen, 2 Meter Stecker, und dann gehen die einfach schön auf die richtige Länge geschnitten. Am Anfang, ja, das ist ziemlich viel Arbeit alles gewesen. Die 3D-Print-Stecker, das ist natürlich flott durch die extreme Flexibilität. Du kannst ihn designen so perfekt, wie ihn das gerne hat. Zum Beispiel das Stecker, die Kamera unhält, oder die Stecker, die du an den Cube ragehen. Oder die kleinen Dinger, die schwer zu sehen, die Kabeln da unhalen, die kleinen Gro und so sind die innen da. Und ja, die kann ich am Anfang alles 3D printen. Und ich gebe auch so, ich habe auch keine Zeit für das auf der Bühne zu so. Wenn ich das dummes Nein machen, gebe ich wahrscheinlich mehr Stecker 3D printen. Also da gebe ich das noch mehr ausschöpfen, weil für selbst aus Aluminium zu machen, ist immer schwer, spärlich, weil das kann ich nicht wirklich selber machen. Da brauche ich schon eine Maschine, für das für zu helfen. Aber wenn ich das 3D printen, hat den Zeit, setzen sich für seinen Computer, designt das, und dann direkt den Print, und dann hat ihn dann noch das Stück perfekt, so wie er das gerne hat.
If you don't mind speaking in English with me now?
Yeah, no problem.
I have a couple of questions. First, what was the most fun part in the project? Was that the hardware part or the software part?
I would say it was the software part, because it was the most complex, and it was the one where I had to do a lot of research, and it was the most satisfying when I saw everything working out. I actually did the software in advance, so when I did most of the work in the Christmas holidays. So when the holidays started, I took 1 week where I did the programming. So I had the program ready, and I had everything imagined in my head, and I could run simulations and then only then I started building the machine, and yeah, everything.
Was it more like a moment where you plugged it and it worked directly, or did you have to try several times before it actually worked?
That's an excellent question, because something happened that never happens. I had tested the software, and I had tested the components individually, like the motors. I knew they worked, the electronics I knew they worked, and the software I knew they worked. But when I plugged everything together, it just worked.
Okay.
And the first solve, it actually solved the cube.
Extremely satisfying.
It never happens. If you have any experience with programming, you know that when you click on start, something goes wrong the first time you do it. So, yeah.
Wie war das für dich, für das Jahr und dem Dutten oder das letzte Jahr und dem Projekt halt zu schaffen? Wie viel Zeit hat es gebraucht?
Also das war schon richtig zeitaufwendig. Also schon mal die Idee, während den Optionskurven habe ich ja am Anfang ausgedacht. Und an dem Optionskur geht am Anfang darum, ein Projekt zu machen mit dem Raspberry Pi, mit dem kleinen Computer, den am Anfang meine Maschine steuert. Und schon natürlich an den Stunden geschafft, aber schon die meiste Arbeit muss natürlich daheim gemacht werden, weil die Zeit geht einfach nicht durch. Und ich gebe so, ich hatte bald mehr Zeit mit dem heutigen Projekt verbracht, mit meiner Premiere bis dahin. Ja. Ich meine, das könnte ich ungefähr. Ja.
Und hast du hauptsächlich allein geschafft, oder von wem hast du Unterstützung für?
Schon natürlich hauptsächlich allein darunter geschafft, aber wenn ich irgendwie Hilfe von jemandem gebraucht habe, die Konstruktion baut sich auch nicht so einfach ab. Da sind 100 Schrauben drin, allein just für die Konstruktion zusammenzahlen, da kann ich dann von meinem Bruder oder meinem Papa oder so, da aber immer für zu helfen. Aber wenn ich froh hat, kann ich auch immer bei sich gehen oder so, oder für den Martin zu packen, das war flott natürlich.
Und dann für den Rapport zu schreiben, den du für den Konkurs aufgehen hast, wie lange hast du da geschrieben?
Ich habe ein bisschen Zeit gebraucht, aber das war am Anfang an der Reihe par rapport zum Rest. Also wenn ich die ganze Arbeit gemacht habe, ich hatte natürlich die Idee schon im Kopf, dass ich selbst mal wählt, wie ich das gemacht habe. Da habe ich auch immer schön Foto gemacht, wenn ich etwas gebaut habe, und ich habe mir gedacht, hey, du hast einen Moment, müssen wir ein Foto, oder du dokumentierst, was du gerade gemacht hast. Dann hast du das dann ziemlich sehr gegangen, und die Sachen zusammen gesicht, was selbst dazwischen gefüllt mit Text, und dann da steht der Rapport am Anfang relativ sehr.
Okay. I have a tiny last one question. I actually find remarkable this project because it shows if you get the first time a Rubik's Cube in your hand, you try to do everything, and then if you learn a tiny bit about it, you know that there are formulas that help you work your way and stuff. So it's really a scientific approach on that. Can you comment on that thing in general?
So I want to comment about how difficult it is to solve a Rubik's Cube. Because many people think, I'm not able to solve a Rubik's Cube, but in fact, you only need to really understand how to solve the first 2 layers. And the rest, you just simply, you cannot go around learning an algorithm. So the last layer, when you want to do the last layer, you have to know, okay, right, up, down, so, and then...
Learning by heart.
Yeah, and you have to learn it by heart, and then eventually it becomes muscle memory, because I'm not even able to solve the cube anymore when the cube turns too slow.
So my final question would be, how fast can you solve a Rubik's Cube with your personal record?
That's a very good question. Officially 24 seconds, I think. And the real personal best I had with official scrambles, I think 17 seconds or something like that.
Wow.
Yeah.
Congratulations for everything then.
Thank you.
Thank you.
Wie viel Rubik's Cube und Huda daheim am Haus? Wo ist
Am Anfang das war ein bisschen verrückt am Anfang. Also dann habe ich schon angefangen mit einem Cube, den ich dann einfach irgendwie so an der Schule gekriegt oder selbst. Und danach ist das dann immer so gewesen, es gibt einen besseren Cube, das wäre schön, den zu haben. Und irgendwie geht dann den 3x3 von einer langweilig und da geht es sich ein 4x4 oder 5x5 oder geht darauf bis zu einem 7x7 am Anfang von offiziellen Puzzlen. Und es gibt auch noch so verrückte Sachen wie ein Dodekaeder, so ein 12 Ecken. Und dann gibt all mögliche Blödsinn, eine Pyramide, so die Pyraminx heißt das. Es gibt all verrückte Sachen. Und schon von all denen natürlich ein daheim. Schon die alle in einer schönen Vitrine in meinem Zimmer. So wie ich das gehört.
Also ist fertig gemacht oder sind sie nach...
Also ich stelle nichts zurück an die Vitrine, was nicht gelesen ist. Also ich meine, es gibt ein bisschen Stehren. So. Ja, aber ja.
Merci.
Ja, merci.
Merci.
Ja.
Perfekt.
Next up are two girls from the San Sofí, Karina Orbelians and Sofia Almeida Carrigado, who attempted to find a nail polish with which one could operate a touchscreen. How can you use a tablet or a smartphone despite long acrylic nails? Well, Karina's and Sofia's project examines possible solutions to this problem. Let's see what they came up with.
Hallo, ich heiße Sophia.
Hallo, ich heiße Carina und wir kommen aus der Schule St. Sophie.
Wir reden heute mit euch über einen Touchscreen-fähiger Nagellack. Und die Frage, die wir uns stellen, ist es eigentlich möglich, einen Nagellack herzustellen, mit dem man ein Touchscreen betätigen kann? Unsere Idee dabei war, dass heutzutage viele junge Mädels sich Nägel aufkleben oder Gelnägel machen oder einfach nur Lack drauf machen. Und wir haben uns dabei gedacht, dass im Alltag oder im späteren Berufsleben könnte es zu einem Problem werden, das iPad oder Handy zu benutzen. Somit haben wir uns dazu bereit gemacht, ein Projekt zu starten, um vielleicht einen touchscreen-fähigen Nagellack herzustellen. Welche Touchscreen gibt es eigentlich? Es gibt den resistiven Touchscreen, der besteht aus einer transparenten Platte und wird in Industrienbereichen, in Fabrikautomaten oder medizinischen Geräten hergestellt. Wir haben auch den oberflächenkapazitiven Touchscreen. Da entsteht, wenn man auf einen Punkt drückt, entsteht eine sogenannte Spannung und damit kann man halt dann an Spielkonsolen oder Spielautomaten betätigen. Und das Touchscreen, was uns interessiert, ist das produktive kapazitive Touchscreen. Das wird in Handys, Tablets oder Computers verarbeitet. Und da gibt es, der Finger ist die zweite Kondensorplatte, die uns dann ermöglicht, das Handy zu bedienen. Was ist eigentlich ein Kondensator? Also ganz einfach erklärt ist, ein Kondensator ist ein elektronisches Bauelement und es speichert die elektrische Ladung oder die Energie, die wir vom Finger abgeben. Und es besteht aus zwei elektrischen Leitern. Wir haben Experimente dazu durchgeführt und haben mehrere Dinge an unserem Handy ausprobiert.
Hier haben wir die vollständige Experimente gemacht. Zum Beispiel Aluminium geht gut, Münze unter 1 Euro geht auch gut, Uhr geht gut, Brille auch, Stiftmühle auch, Eisen, Zink, Aluminium und Kupfer gehen auch gut. Eine Brille geht gut, Pinzette nicht so gut, also geht nicht. Batterie 1,6 Volt, volle Batterie, negative Seite ja, positive Seite nicht. Batterie 0,18 Volt, also eine leere Batterie geht gut, mit einer negativen Seite geht gut und mit einer positiven Seite nicht so gut. Hier sind die Obst und Gemüse. Mandarine geht gut, Mandarinenschale auch, Möhre auch, Eiswürfel auch, Finger 0,08 Volt, also auch. Dose, eine volle Dose geht nicht gut, also eine volle Dose geht gut und eine leere Dose nicht gut. Wasserflasche ohne Wasser geht nicht und eine Wasserflasche mit Wasser geht. Bleistiftmine nein, Gummikappe nein, Thermometer auch nicht und Korken auch. Die Auswertung, also Metalle gehen, außer es sind kleinere Metalle. Kunststoff funktioniert, außer Wasser vorhanden. Gemüse, Obst gehen auch, außer es ist getrocknet sowie Bohne, also so wie eine getrocknete Bohne oder Mais. Batterien gehen auch mit einem Minuspol. Mit einem Pluspol geht es schlechter und nicht bei jedem Handy.
Kommen wir zum Ergebnis. Also die Frage, die wir uns ganz am Anfang gestellt haben, ist, kann man einen Nagel herstellen, mit dem man ein Touchscreen betätigen kann? Und wir sind zu dem Ergebnis gekommen, dass man es theoretisch machen könnte. Man könnte einen Lack oder einen Klebstoff mit Silber oder Kupfer vermischen. Jedoch würde das Lack dann abfärben und das würde halt nicht so gut aussehen. Und man braucht eine größere Fläche, wo man es aufträgt, damit das dann geht. Wir haben es zum Beispiel mit einer Aluminiumfolie ausprobiert und je kleiner die Fläche wird, desto weniger es funktioniert. Ja. Und hier haben wir es aufgezeigt. Wir haben ein kleines Aluminiumstück auf den Finger getan und es am Handy ausprobiert. Und je kleiner die Spitze wurde, desto weniger Widerstand hat man und desto weniger hat es funktioniert. Hier sind die Quellen, wo wir alles nachgeschaut haben. Danke fürs Aufmerksamkeit.
It's now time to invite Anthony, Ariaman, and Andrew to learn more about earthquakes, AI, and science.
Thank you guys for joining me here. How did the three of you know each other? Where do you know each other from?
Should I answer this? Yeah, go ahead. All three of us are classmates. We're in the same class at the Athénée de Luxembourg.
And you've been in the same class for a while?
It's our third year?
This is our third year. He's been here since Cesium. Yeah.
And how did you come up with doing this project? How did that come about?
So we're great fans of chemistry. So we're all doing chemistry HL, and we really, I think we all like the geology aspect of our chemistry class. So we were like, why not do this?
But if you look at the project, like when people think about earthquakes and like analysis that goes with it, like it's actually, to me, it's pretty intimidating. It's just, I imagine a huge set of data that can go in every direction possible with thousands different scenarios. Was it intimidating for you to start such a project?
Should I answer? Well, I mean, for us, it was just mainly, it was more interesting than it was intimidating, because we were just looking at the data set, and since we also love math, we just found it very fascinating, very interesting.
And how did you find out about the data that is available to look at?
So I've heard of this website called Kaggle, and we found this nice data set from the Los Alamos Institute. So we were able to really acquire some really good data.
Did you start the projects because you found the data, or did you start the project and then we're looking for appropriate data to back up the actual idea?
Well, I mean, first of all, it was interest, and then we were able to find the data set off of that.
So yeah, we specifically looked up for some seismic data after we thought, like, this would be a really fun idea. So.
And as I said, it's probably a huge set of data and probably going in every direction. Like, were you alone doing that and then digging into that and trying to find did you get some help for that?
Well, I mean, we all did it, like, us three researched
okay.
the entire project by ourselves. So.
Yeah. And then in terms of the data, it's enormous. It was a 9 gigabyte file or something for Excel, just 6 million something rows or something.
I guess, yes.
It was definitely intimidating, but we had a lot of fun.
What was it like working together in a team?
You can say it, go
So sometimes it was hard because it was getting annoying when we didn't find what we wanted to find, but you just push through and we support each other. So.
Did you have specific roles within the project, or like did you really work all together and developing all at the same time?
Yeah, he did mostly the coding and the AI, and we did the research presentation.
Okay.
Yeah, and Andrew made the graphs and everything for the presentation and the research.
And how long since starting on the project until completing it?
Oof.
When did you start? When did you first start?
I mean, we started like at least December.
I think last year or
at
something.
Least, yeah,
quite a while.
Was it time consuming overall?
I mean, we like putting in a bit of consistent effort, but at times we worked harder than other times, you know. So a bit of balance.
Mm-hmm.
How did you juggle the work that needs to be done on the project and your schoolwork and other commitments?
Do you want to answer?
Yeah, well, at school we have a different timetable than other students. We have a bunch of holes in so we have 2-hour breaks, so we usually did
so
that
you could
time.
use some of that time to then work on the project and so on. Yeah. And is this the first time that any of you participated in the contest?
No, last year we, us two, did a project on license plates.
Okay.
Yeah.
Mm-hmm.
And this year
This
you
is
joined
my first time. Yeah.
the team. How does the experience compare from last year and then this year?
I think it's this year. It's going to be a lot more fun, especially tomorrow or on Sunday when we get to see everyone and less masks, of course.
Yeah.
So.
Yeah.
I have a question for you then. It's like, how did they convince you to jump in this time?
Oh, well, I mean, I heard about when they did the project last year on the license plate, and that was just really interesting to me, and I just wanted to hop in, and it's a new experience, you know, so it was just something that as soon as I heard about it, I was like, I want to get in. To jump into the next project.
Did you have a look at their project in detail from last year?
I did actually, and yeah, I like the idea. So joining the team was good.
Okay, and the original input, like from going to license plate to earthquake, who had the idea?
Well, I think all of us, we kind of wanted to do something on earthquakes, and
because of the interest of geology.
Yeah, and I obviously, as we wanted to do something on earthquakes, I had the coding knowledge so that we can actually do something. It's a bit similar as well to last year, as we also did an AI detecting the license plate and making a system behind this. So I felt like our idea, along with some coding, would be a really cool idea to make.
Okay.
Yeah. Well, thank you very much for your time.
Thank you.
Our next project was designed by Sophie Barberon from the International School, who developed an educational application to support French learning for adult refugees in Luxembourg. Since her birth, Sophie has lived in 4 different countries and has been around people from all over the world in her schools. She experienced firsthand how challenging it can be to learn a new language, depending on what your mother tongue is. Let's hear more about her amazing app.
Thank you. So my name is Sophie Barberon, and my project is called Bien Lire. It's an application for iOS. So there are 5,000 to 8,000 different languages in the world, and they're different by their sound systems and their grammatical properties. During the learning of a new language, acquiring and mastering the sound system is a first obstacle. Around the world, there are 12 to 141 different speech sounds, also known as phonemes. For example, English has 44, and Xun has 141. So you can really imagine the difficulty for an English speaker to learn Xun, which includes learning sounds which they aren't familiar to hearing nor producing in their home language. Now, about French, one of the 3 official languages in Luxembourg, and which people arriving from abroad must learn. It has 36 speech sounds, including 16 vowel phonemes, and these 16 vowel phonemes are made up of the 6 vowels. And they're especially hard for French learners because they don't usually exist in other languages. I was first aware of this when my Japanese relatives would pronounce Luxembourg as de Luxembourg, because the U sound doesn't exist, they'll replace it with E, and the En sound doesn't exist, they'll replace it with E. And as you can see, the end result, de Luxembourg, is quite different from Luxembourg. So scientifically, this makes sense. When you look at the decomposition of vowel sounds by frequencies, on the left, you can see that Japanese is made up of has 5 very distinct vowel sounds, compared to French, which has a lot more, and they almost overlap in some areas. So I became interested in learning how the closeness of sounds might impact someone's learning of French. After visiting some refugee French classes in Luxembourg, I obtained some students' dictation tests, and I could confirm that, for example, Eritrean students could very hardly differentiate between E, U, and O. You can see in the dictée. And it makes sense because these sounds simply don't exist in Tigrinya. So with this in mind, my goal was to create an app to help adult learners with pronunciation and reading. So here is the general workflow with the screen transitions and button actions of my app. When you first open it, it takes you to the first screen. You can choose to learn sounds, or you can choose to read words and then choose a sound group that the word contains. And then you can practice reading and your pronunciation. Yeah. So to build the app, I used Xcode. And as a programming language, I used Swift. This is how Xcode looks like. On the left, you can see a column with the file navigation tab. In the middle, you can see the actual coding and writing area. And to the right, you can see a live preview provider, which is really useful because you can see live modifications of your code on a device. So since building applications was completely new to me, I wanted to share some discoveries that I personally made. So I first learned that applications were built by designing screens, and in Xcode, these screens are called views. I learned how to create buttons and use sounds, which was made a lot easier because you can import libraries, and so all the complex code is already written for you. It knows, for example, what a button is, and so all you have to do is specify what the button action is. So in Swift, you have basic variables, but you can also create a custom type of variable, which is what I did to modelize what a word is. Because in my app, each word is made up of an ID, a name, a group name, and a sound name. I also learned how to use data files, because this is important because of the volume of words that I will add in my app. And so in the end, I think it was not only interesting to learn how to actually code, but also how to deal with a coding project. I used mostly YouTube, and something that was new to me was working with GitHub, which is a platform where you can work cooperatively with others on code. And so the last step would be to publish my app on the App Store, but it does cost some money. There's a yearly fee, and so this SWOT analysis can help to see if it is worth it. So I think the biggest strength for my app is that it's tested by, and it's made for users, and I collected their feedback regularly. A weakness, though, is that it only works for iOS, and 80% of the refugee population in Luxembourg has Androids. So an opportunity is that there are basically no French reading apps for adults which are free and which are available offline. But a threat is that the biggest unknown for my app is that I don't know how much space it's going to take on a device once I add all the words in and all the sounds. And so lastly, here's a video of a Syrian student using the app. I would like to thank her for helping me.
Avoir.
Avoir.
Moi.
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 Thank you very much. Without further ado, let's have a little chat with Karina and Sophia to learn more about their innovative ideas.
Merci, dass ihr hier seid. Hallo, wie lange kennt ihr zwei schon?
2 Jahre. Ja, wir haben uns am Lycée kennengelernt. Ja. Also seit 7. wir sind Luciam und ja.
Und wie findest du also die Idee gekommen, für dieses Projekt zu machen?
Es war zusammen. Also, wir waren am Kurs und wir hatten halt lange Nähe. Und dann sind wir auf die Idee gekommen, dass es vielleicht schlau wäre, etwas zu erfahren, für das sie besser eingeht an der Schule, gerade mehr Mädchen.
Wir hatten eine Aufgabe am iPad gemacht und eine Kollegin hat lange Mail und sie ist nicht gut hinzugehen, iPad zu schreiben.
Ja, okay.
Ja.
Cool. Und wen hört ihr Stunden, also wer ist das gegangen, dass er die hat und dass er dann nur...
Am Anfang war es mehr so als Witz, wo wir so gedacht wir haben von interessant eine Forschung daraus zu machen. Und da haben wir mit unserem Science-Prof drüber geschwatzt, dass man vielleicht könnte probieren. Und da haben wir halt verschiedene Experimente gemacht und geguckt, was geht. Ja.
Und war das dann noch ziemlich zeitaufwendig, das Ganze?
Es geht, ja. Wir haben halt auch während der Schulzeit viele Sachen ausprobiert dann halt. Und ja, also es war schon ein bisschen zeitintensiv. Ja.
Und funktioniert es auf Tablet am Handy oder gibt es da Unterschiede?
Nein, weil das ist nämlich den Touchscreen. Ja. Also wir haben ja noch kein Produkt festgestellt, aber von der Technik oder von der Forschung her müssen es auf den zwei gehen.
Ja. Okay. Das heißt, dass da noch die Echtkeit, dass da bei diesem Konkurs mitmacht. Ja. Wie war die Erfahrung für euch?
Stressig. Ja, stressig, aber ich finde es flott, mal etwas anderes zu machen. Etwas mit großem Publikum und alles. Ja. Und war aber flott.
Nicht, wenn wir für eine Klasse zu präsentieren, auch für eine Jury. So.
Oder dann noch ein Projekt an der Klasse vorgestellt?
Nein, wir haben nicht paar Freundinnen halt vorgetragen und erklärt.
Für schwer zu reden,
ja.
für Leute heute. Ja. Der hat nur eine Präsentation gemacht und dann noch mit der Jury nach müssen schwatzen. Ja. Wie war das?
Ich fand flott, dass sie als Idee gehen und erklärt haben und auch Fragen gestellt haben, für das man das nächste Jahr verbessern könnte. Und ja.
Hat er Lust für nachher etwas weiter zu machen, vielleicht heute mehr zu entwickeln? Oder?
Ja, wir hatten die Idee dann halt weiterzumachen, auch nur mit den
Feedback.
Genau, mit Feedback mit der Jury. Wir müssen halt nicht mehr gucken, ob es dann halt auch wirklich geht. Also wir hatten schon die Idee weiterzumachen. Ja.
Wie habt ihr über Jugendforschung herausgefunden? Wer ist dazu gekommen, dass da...
Weil seit ja wusste man, dass es das gibt, weil wir halt auch drüber geschaut haben in der Klasse. Und da sind wir halt dann zu dem Punkt gekommen, das Jahr dann da mitzumachen, weil wir uns ein bisschen informiert tun und tut uns gefallen. Und dafür, ja.
Hat ihr dann Projekte von anderen Kandidaten letztes Jahr oder das Jahr angeguckt?
Ja, auf YouTube haben wir uns ein paar Videos angeguckt. Und voilà, wir haben halt mega interessant gefunden, dafür haben wir halt auch mitgemacht.
Und kennt ihr irgendwelche von den anderen Partizipanten?
Nee, leider nicht.
Okay. Ja. Wie sieht der Rest vom Programm aus für euch während dem Konkurs? Also haut sie da fertig, morgen braucht ihr nächstes Mal und da sind da Sonntag nach dabei.
Ja, besonders kommen wir nach in Carina und stellen dann, also Leute kommen dann und machen dann ein Plakat und erklären dann ein bisschen mit verschiedenen Sachen und ja.
Und Familie und so also auch mit dabei für euch zu unterstützen?
Ja.
Cool. Ja. Well, das war, ja, das hast gesehen, Carina, du hast lange Nägel und du hast echt eine Kürze und so weiter. Ja, schon, ja, wenn sie noch, ich habe am Anfang von der Woche geschnitten gehabt, für können Touchscreen zu hören, habe ich wieso kein Problem. Aber schon nach eine gute Bank für euch. Interessiert dich dann noch am Allgemeinen für die Wissenschaft und alles?
Ja, also mit zwei, wie gesagt, auch an der Schule, wir sind halt immer zusammen, wir machen auch viele Sachen dann auch an der Schule zusammen, auch Experimente, TPs am Science-Kurs und alles, hat euch schon immer viel interessiert und ja.
Cool. Ja. Am Anfang würde ich keine weiter Fragen mehr nach für euch. Mit den Interviews auch noch nicht gerade rüber. Aber welche Hobbys habt ihr danach?
Halt, wir gehen oft mit Kollegen raus, so was Teenager so immer ein bisschen machen.
Wenn es der Schule mit den Hobbys wie Tanzen,
ja, auch in der Schule haben wir Aktivitäten, die wir machen können. Und voilà, wir beschäftigen uns ein bisschen damit an unserer Freizeit.
Ja. Gibt es dann, könnt ihr euch auch vorstellen, für an der Wissenschaft weiterzuschaffen?
Ja, ich finde eigentlich immer Science immer gut fand, mega interessant und spannend, weil das auch vielfältig von allem ein bisschen etwas. Und ja, vielleicht mich später hin auch am Lycée irgendetwas machen oder als Beruf dann auch mich später etwas. Ja.
Ja. Cool. Von den Preisen, die Leute kriegen, die mitmachen, hast du ein bisschen informiert, was es so von Optionen gibt?
Also uns waren Preise nie wirklich wichtig. Wir haben echt als Präsentation viel gehalten und als wichtig angesehen. Und Preise sind Sachen, die kriegen dann halt nur dem. Mir das nur nicht als ein Bild von dem Ganzen halt.
Kannst auch mitmachen.
Ja. Aber gebe dir schon freuen, wenn da können zum Beispiel bei einem anderen Konkurs mitmachen, international?
Ja, natürlich, ja.
Okay. Cool. Ja. Ich sage einfach schon mal merci für dass ihr auch noch hier wart und so weiter. Dann
Our next young Fuerscher, Gonzalo Rafael Fonseca Correa, is a third-time participant of the contest. This year, he will be presenting his climate protection engine that doesn't produce any CO2. But let's hear directly from Gonzalo what his engine is all about.
Heute präsentiere ich erst mein Motor, den 100% freundlich von der Natur ist. Mehr eher, dass wir verschieden waren, mehr neue Motor brauchen für das Auto, muss mehr verstehen, die Autos, die jetzt schon gehen, und die Vorteile und die nicht gut. Den elektrischen ist gut, mich keine Waldverschmutzung während die Fahrt, während dem vom Benzin das schon möchte. Aber man muss nicht vergessen, dass eine elektrische Batterie benutzt, und die Batterien sind nicht 100% recyclabel, weil beim Benzin den Auto schon alles recycliert kann gehen. Dann fange ich mit meinem Motor an, mit dem ersten Teil aus die Maschine, die Druck möchte, dann geht dann an den immer Druck gehalten, und dann kommt dann ein Druckmotor, den aus CO2 aus. Den gesagt und dann so aus dem Motor. Der Druck wird den Pisten 1 nach oben drücken und den 2 nach unten. Nur geschieht ein Prozess, dass den Zyklus wird umdrehen und den 2 wird hochkommen und den 1 wird immer mehr hochkommen. Nur dem Prozess geht den Druck aus, geht den Druck fort, und dann sind die 2 Pisten equilibriert. Da sieht das so aus. Den zweiten Teil, mit der Rotation vom Druckmotor, können wir dann Strom herstellen, und wir können dann Elektrolysen machen. Den Prozess können wir den Wasserstoff und den Sauerstoff vom Wasser trennen mit Strom. Mit der Rotation, da sehen wir, wie immer mehr Wasserstoff und Sauerstoff produziert wird. Und dann der Brennstoff vom Hydrogen. Denn da wird kleine Explosionen geschehen, wie beim Benzinauto. Die wird die Pisten dann nach oben machen. Aber was gut ist beim Hydrogen, als wenn er verbrannt geht mit Sauerstoff gemischt und kommt dann Wasser raus. Das Licht kommt kein CO2 raus, aber so Wasserdampf raus. Das sieht dann so aus. Und dann sieht er eine kleine Explosion. Die war ein bisschen stark, obwohl da nicht viel Hydrogen dran war. Das ist etwas Gutes vom Hydrogen. Aber wir haben dann noch ein Problem beim Wasser, das wir benutzen für die Elektrolyse, hat noch Salz, den heißt NaOH, und den darf man nicht einfach in die Natur gehen. Und wir haben auch ein anderes Problem, den CO2, den vom Druckmotor kennt. Den haben wir nicht einfach in die Atmosphäre, sondern wir holen den, wir machen den in ein Aquarium mit dem Wasser, und da könnt ihr Photosynthese mit den Algen, und da können wir sauerstoffreichen Wasser rauskommen, und nachher kann der Prozess von der Elektrolyse machen. Aber dann geht nachher ein Teil vom Motor, einen elektrischen Teil, der nicht Explosionen benutzt, und dann ist es noch weniger gefährlich. Du hast eine Membran, die mischt den Hydrogen mit Sauerstoff, die mischt den Strom, und den Strom können wir an einem elektrischen Motor machen, und dann können wir mit dem Auto fahren. Das ist ein elektrisches Auto, das keine Batterien hat. Und das war es. Merci.
With your project idea to create an app to learn French.
Hello, yeah.
Congratulations for your project.
Thank you.
I would just start, if you don't mind, about the question with your family, because we had Marie, who is currently presenting on stage, then we had your sister last year, then we have you. When are we going to get the fourth sister?
So Marie started, I think, like 3 years ago with her first presentation, and then Charlotte joined last year, and I joined this year.
What motivated you actually to join them? Like, was that inspiring what they did?
Yeah, I think it's because every time they presented, they came here, they just always came back with a positive experience, I guess. And they just, they encouraged me to do it. They told me that no matter like how it goes, it's going to be an experience that, like a good experience, I guess.
Everybody's a winner here, yes.
Yeah, that's what they told me. So.
Yeah.
How did you come up with how did the idea to do this project come up for you?
Yeah, so I'm going to kind of say what I said in the presentation, because it first started when I noticed some difficulties with my relatives who couldn't pronounce certain letters or sounds in French. And so I went to the Christ-Roi, which is like French classes for refugees in Luxembourg. And again, I obtained some dictation tests. I could see that they struggled with sounds. And so I thought, why not make an application which they can use at home? Because, for example, with COVID and everything, it was harder to actually attend in-person classes. So they had less class time. So I wanted to make an app that they could use at home and that they could use like repetitively, because that's what helps to actually learn and for a sound to actually stay in your mind.
Yeah. And did you see a difference between people using the app making more progress depending on what their mother tongue was?
I actually haven't done that kind of testing yet with users, so I'm not sure yet. But
you were mentioning during jury questions that it could be an area of improvement and the possibility for coming back next year with the same projects.
Yeah, it could be.
Okay.
More testing, and then because I'm planning to keep working on the app, so definitely there will be more testing, and yeah.
And how time consuming is it to work on it? How time consuming has it been to work on the project?
So I think I didn't really, I can't tell you, like, for example, a number of hours, because I watched like YouTube videos to teach me, and then along the way, I kind of just learned little bits. And so maybe it's like an hour each time, but not every day, like, I don't know. But sometimes I did stay up quite late to do the code, to learn code, but there wasn't really a forced feeling because it wasn't like a project of school, so it was nice.
And which bit did you enjoy most working on the project? Meeting other people, so when you went into the refugee center, or working on the more background research?
I enjoyed the background research, but also working with the refugees, with the users, because I learned how vowels sounds, for example, can be split up into different into their frequencies, and we can see like how hard it might be to pronounce these sounds. And I was so interested that I did. I'm planning to do another project, like math related with this. And so the background information was interesting, but also I found it interesting to meet the users and students. Yeah.
Super. Yeah. Do you have? Did you meet any of the other participants in this year's contest? Do you know any of the other contestants?
I know that a lot of people from my school in the grade above are presenting their projects. I also have a friend who's doing her project. Yeah.
Do you have any last words of encouragement to them?
I think like it goes by really fast, and like when you're up presenting, it's like in front of you there's only the jury. There's not like a big crowd, so I think that really helps to ease your nerves. So
Thank you very much.
Thank you.
Thank you. Thank you for having me.
And we've got a goodie bag for you.
The next Jonk Fuerscher coming on stage are Fyodor Stanica and Christopher Gargiulo. They will introduce their project titled Analyzing Energy Production Methods and Viewing Luxembourg's Energy Inputs in Relation to these methods. With today's ever-increasing energy production needs and the limitations of current energy sources, such as fossil fuels, this puts Luxembourg in a vulnerable position. Therefore, this project will be focused on finding solutions to make Luxembourg more independent by increasing the generation of energy on a national level.
Hello, I'm Fyodor Stanica, and I'm here with my partner Christopher Gargiulo, and we will be presenting energy production methods and their applications in Luxembourg.
Yeah, so we are students in the Athénée in 4e and we're 14. So before we started, we had to create a hypothesis where we gathered all the energy generators we could think of, like the main ones, and we thought that the nuclear power plants and hydroelectric generators would potentially be the best choice for Luxembourg. Now, before we get into the details, I will explain what energy is. Now, energy is found in all objects everywhere, and the key to making it into electricity is by containing and harnessing the energy, and through kinetic energy and thermal energy, we can convert it into rotational energy with turbines, magnets, and wires, is then converted into electricity. Now, the 5 main types of energy generators we will focus on are the nuclear power plants, the fossil fuels, the hydrological methods, the solar methods, and wind turbines. Now, nuclear power plants. Nuclear power plants get their energy through a process called nuclear fission, where they split a uranium atom, which produces large bursts of energy, which is contained and generated into electricity.
What are the benefits of nuclear power plants? Well, first off, they produce tons and tons and tons of energy while they're working. The other, benefit is the fact that it's quite cheap considering what it is, and as well as it being good for the environment under certain circumstances.
However, there is nuclear waste produced by these power plants, and if not contained properly, can be devastating towards the environment, as the nuclear waste is very deadly. Now, fossil fuels?
Yeah, how do fossil fuels represent energy? Well, fossil fuels, they can either be burned to produce thermal energy, or they can be refined and put into automobiles and directly be used like that. The benefits of fossil fuels are simply the abundance of it in nature and the small effort in the process it takes to actually make them usable as a fuel source.
However, as we all know, it produces CO2 and methane, which are greenhouse gases responsible for global warming as they contain the heat into our atmosphere. Next are the hydrological methods. Now, there are many different methods using water, such as the water wheel, hydroelectric plants, and wave-star technology. Now, they convert the kinetic energy of the waves into electricity.
Yeah, the benefits of hydrological power plants are the high efficiency that it has, with upwards of 90% efficiency rate, and the low impact on the environment that it has where it is being placed.
However, they are pretty expensive per cost per kilowatt at around 85 cents compared to the other generators, and they can damage the ecosystems around them.
Solar panels produce energy by absorbing sun rays and producing thermal energy through that, and which is then converted into electricity. The benefits of solar panels are that they're highly commercial, which means that they can be bought by anyone, and anyone can buy it and easily implement it in their day-to-day life, which, since it's green, is a really big benefit, as anyone can do their part in helping the environment by using less carbon-based energy.
But there are some disadvantages. Because they are quite commercial, the prices per kilowatt is quite high, from 70 cents to $1.50, compared to the others is the highest. And they have an expiration date from 10 years to 25 years, and once they expire, the materials that are made of them are not very recyclable, accumulating waste, which is quite bad for the environment. Now, wind turbines, they convert the kinetic energy of the wind into rotational energy, which is converted into electricity.
The pros of wind panels are the fact that they need very little infrastructure to actually be able to work. As you can see, they are on the field. They don't need to be near a city or have a huge power plant around them for them actually to work. They're also very good for the environment, as they do not produce any greenhouse gases.
But there are some cons, such as they are only put in certain areas that are windy, and because it relies so much on the wind, and if the wind simply doesn't blow, they're just unreliable, and they're not a definitive solution.
Here we have made a small table which represents the 5 production methods we mentioned, and based on their price and their efficiency, we have ranked them using colors to simplify things. And as you can see, nuclear and hydro-based came in first with 8 and 7 points, and this seems to prove our hypothesis correct. However, it's not exactly true, as Luxembourg is very dependent on its neighboring countries and also does not have the infrastructure or locations needed to put and place these power production methods within them. So we have created a hypothetical situation within ourselves where if Luxembourg had the resources needed to build such things, where would they place them? And as you can see, the nuclear power plants, there's perhaps 2 possible locations, in the north and in the east. And, well, obviously, not both of them have to be there. That'd be a ton of energy for a country the size of Luxembourg. And we've also placed, for example, wind turbines along windy areas, solar panels near the cities, and hydrological power plant in the lakes. So what is the conclusion? What have we found out in this presentation? We found out that hydrological and nuclear power plants are the most efficient based on price and location, as well as their effect on the environment. However, Luxembourg does not have the infrastructure and resources needed to build these things. So what is the solution? How can we make Luxembourg a bit more independent? Well, what we suggest is, well, solar panels, because since they're so commercial, they don't have to be implemented severely, and just a small encouragement for Luxembourg citizens to become more green and buy solar panels could really improve the energy production rate.
Thank you very much for your attention.
And we go back to Gonzalo so he can tell us how sustainable driving might look like in the future.
Merci, dass du hier warst. Ich habe gut gesagt, dass du letztes Jahr schon teilgenommen hast in diesem Konkurs mit dem B-Robot. Wie warst du gekommen, für dieses neue Projekt zu machen?
Es war am letzten Sommer, da waren viele Naturkatastrophen. da war im Kanada, ich mein, Tornado, den USA, Waldbrand an Europa, die Wasser. Ja. Und dann hatte ich eine Idee für ein Motto zu machen, den CO2 benutzt.
Ja. Und mal erzählst ein bisschen mehr am Detail. Also woran hast du dich inspiriert, für die Maschine zu bauen?
Schon Auto gern an der Autoindustrie an. Schon auch gern den Energie von waren viele Wissenschaftler, die da doch gemacht, wie den Niklas Gläser, wo ich auch ganz gern. Und er hat sein Leben lang auch nicht an Experiment, nicht nehmen, aber meistens mal die Experimente mit Strom gemacht.
Ja. Du hast schon Ideen für das Projekt noch weiter zu entwickeln?
Ich hatte Lust, das Motor an ein Auto zu setzen, dass ein Auto funktioniert.
Ja. Also für den Auto zu testen und zu gucken, wie nützlich das du an dem Kader ist.
Wie potent ich war.
Ja, du interessierst dich viel für das Thema Klimaschutz und für Wissenschaft. Für wo denkst du, könnte das hier dein Interesse für Wissenschaft?
Das einfach so. Cool.
Das ist einfach du.
Ja,
cool. Aber hast du welche andere Interesse hast du danach?
Autoindustrie, Stromindustrie. Auch ein bisschen programmieren.
Ja. Schon dafür muss merci für die Zeit. Schon noch ein kleiner Goodie-Bag für dich. Und dann, ja, so viel muss merci, dass du auch noch hier warst.
Ladies and gentlemen, thank you again for watching the 51st edition of the National Jonk Fuerscher Contest. Before it's time to take a longer break, let's welcome Sven Fielitz on stage for an incredible football freestyle performance. Sven is a professional football freestyler and one of the top athletes in the sport. His journey started in 2006 when he got inspired by other freestylers on the internet. Enjoy this unique performance that creates a bridge between art and sport.
Thank you, Sven, for that amazing performance. Before we take a break, let's have a quick chat with Theodore Stanica and Christopher Gargiulo to learn more about their projects.
Thank you very much for joining me here. Can you do anything as fanciful as we just saw on the screen with a football?
Maybe a couple tricks, but not as
long
yeah.
as that. Me neither. Well, first of all, how do the two of you know each other?
Well, we are very good friends at the Athénée. We've been in the same class for 4 years now, and we haven't really done many group projects together, and we saw this as an opportunity to finally work together on something we were both interested in.
Yeah. It's the first time that you take part in the contest?
Yeah, this is the first time.
And how did the idea then develop to do this project together?
Well, when we started out, we didn't think much about what we're actually going to do. We just knew that we wanted to work together, basically.
Yeah.
So as time progressed, we each had our own ideas that developed, and they eventually kind of merged into one and developed even further into what we have now.
But the topic of energy production, how did it come up?
Well, at first, he had an idea of doing something more psychological, but I wanted to do something more of like energy generators and their effects. And first, when we came to the conclusion to do the energy generators, we first wanted to do it on a global scale. But seeing as how much time it would take and effort and a lot of research doing a global scale, we took more of a national approach and decided to focus more on Luxembourg's energy production and try to make it more independent, because when we heard like 80% of the energy taken from Luxembourg is from abroad, we wanted to make it more independent.
So that didn't sound very reliable to you in the future to have energy coming in?
Yeah, because like in this situation right now, with the Russia-Ukraine conflict, with the Russians cutting off the gas supply, or the EU cutting it off from Russia, we need to have a more reliable and more dependent for ourselves in Luxembourg.
To be self-sufficient.
Yeah, the effects that Russia's war is causing is, well, it can be seen globally, like the gas prices increasing. It's clear to see, and those problems wouldn't really be happening if each country could make their power individually, and it's a benefit since you never know when these things could happen, right? No one saw this coming.
Yeah.
And in the future, what source of energy do you think Luxembourg is going to rely on the most?
I'll add on to it.
Well, in the future, assuming some of the issues with this production method has been solved, and assuming Luxembourg will need way more energy than we need now, since as we're heading towards a more electronic era, we are thinking nuclear, since eventually, like the waste problem, how to fully keep it safe and not let it harm the environment or the people around. If that's solved, there's not really any downsides towards it, and since it produces so much energy, it would be perfect to how the world would be turning out.
Moreover, the also hydro-based energy generators, they are very compatible with others like wind turbines and solar panels. So in only one installment, you can have a lot more energy generators, not only from the waves of the kinetic energy of the waves, but also from the wind and the sun.
It's more reliable in that sense. What are the downsides? At the moment is the waste that is dangerous.
Yeah, and the effect on the environment.
Yeah. What are your plans to develop your project further?
It would be interesting to see the energy production methods in way more detail, like exactly how energy is produced within them, their mechanisms inside them. That could be really interesting to see how they work. That could give better insight perhaps than just numbers and figures on a
Yeah, we can look at how much energy Luxembourg needs as a whole and its prediction of how much it will need in the future. And from these numbers, we can have a combination of certain energy generators, such as maybe nuclear and some solar, that will cover the whole energy that Luxembourg needs.
Changing topics a little bit, how did you enjoy presenting and then speaking to the jury afterwards?
Afterwards or like?
Well, just now, as in just before the interview. After the presentation.
Well, they gave some really good criticism. We appreciated it. We recognized that they were right with some aspects of it. And well, before the presentation, it was a bit nerve-wracking.
Yeah.
But during it, we just already knew what we were going to say. We knew the topic well, so it wasn't much of an issue actually during.
And you discussed beforehand who was going to do which bits of the presentation?
Yeah, well, at first, because we went to this Science Next program where they taught us how to present, and we had an idea of making some sort of good cop, bad cop situation where he would do all the pros and I would say all the cons. Sure, I'd antagonize myself, but I would embody the skepticism of the audience. So.
Yeah. Good stuff. Thank you very much for your time. I've got a goodie bag for you. And I wish you the best of luck for Sunday, for what you have to do on Sunday.
Ladies and gentlemen, welcome back to our live stream of the 51st National Jonk Fuerscher Contest. Agrima Mather and Barbara Diaz from the AED School should have presented together the invention intended to provide energy and water to remote areas by using renewable resources. Their honorable goal is to develop a means for remote areas with harsh environmental conditions to generate water and energy at the same time, in an ecologically safe way. The idea consists of a structure that combines solar and wind energy. Please welcome on stage Agrima.
Hi, my name is Agrima, and I will be presenting the Mather-Diaz structure. Unfortunately, my partner could not be here today, but I will be presenting on her behalf. So our idea came out of a concern about the impact about climate change is having on our environment and on our planet. And our dedication to help and act towards effective solutions to this problem. We are members of a generation which are deeply concerned about the impact climate change has on our planet, and we want to be part of the change in this matter. Our generation has become accustomed to the various crises happening all around the world. When we attend all these climate protests and sign petitions, we have come to realize how unfair living conditions have become for people in remote areas. We realize that we need to make a change. As of 2021, 40% of the entire world population does not have access to sufficient clean water. And as this number increases every year, we stand idly by. 13% of the world does not even have access to electricity. These basic human necessities need to be met. Well, you might ask yourselves, what are the possible solutions to this problem? Well, we already use renewable energy, don't we? We have solar panels. They produce energy from harnessing the sun's light. Why not produce more of those? We have wind turbines that also produce energy in the harshest conditions of the desert. So why not produce more of those as well? We have water tanks to store water and dew towers that already exist. Now I ask you, why invest in these solutions when you can invest in a solution that solves all of these problems at once? Our solution integrates all of these technologies into one structure, allowing it to produce water, electricity, and energy to be consumed by the structure itself. An average household in the city needs about 20 to 24 solar panels to be able to cover 100% of its electricity usage in just one day. Now imagine the impact of 20 such structures, being able to produce much more. With the help of wind turbines as well, that even in the harshest conditions produce up to 10 kilowatts of electricity in just 24 hours. So how does our structure work? The solar panels on top, as we all know, harvest the sunlight to be able to supply energy to these houses. As these solar panels supply energy, any surplus of energy can be directed towards the wind turbines in case there is a lack of natural wind. The turbines are there to draw air inside the structure to travel down to where the temperature is cooler compared to the temperature outside. It then condenses the water on an acrylic sheet, which will then move the then condensed water to a water containment unit under the ground. Since the temperature under the ground is cooler, it is guaranteed that the water will not evaporate. So how does this structure impact our society? With this technology, we can effectively eliminate the water and energy crisis in many parts of the world. Not only is this technology capable of supplying water and electricity to villages in need, but also supply it in a much more ecologically safe manner. With the continued use of this technology, we are able to improve the condition of many third world countries. But in the end, it all comes down to the future of our population. We have a vision. In our eyes, these small but significant steps can lead to a thriving civilization. The improvement of quality of life in remote villages, along with access to basic human necessities. Let us together work towards our future. Thank you.
Remember Sven's amazing performance from before the break? Let us have a chat with him to learn more about his professional path.
Bonjour Sven. So thank you for coming here and thank you for this show. Just wanted to ask you, because your art is a bit peculiar, like it's not something that we see every day. Can you tell us a bit more about it?
About freestyle football in
About
general?
freestyle football, yes.
Well, most people think it has to do something with football, but it's quite different. The only thing that's common is actually the ball. But yeah, it's more similar to dance, I would say, because I also implement some b-boy movements in my freestyle. So yeah, it's just about free expression and creativity and just showing yourself on stage or not on stage, it depends. But yeah, just it's about freedom and yeah, showing what you can do with a ball.
Would you say that you started your interest for the discipline more because you were interested into this kind of dance and freestyle, or because you were interested about football?
Well, in the beginning, I played football in a team, so that's how I started to get into freestyle. But at some point, I got away from just doing a few simple tricks, and I sought inspiration in dance, and that's how I found my own style as well, a style which is defined a bit by the flow. So I tried to put the tricks together in a way that they connect to each other, and so it's not just one trick. I keep juggling, I do the next trick, but I want to create a flow which is kind of flawless, simple in a way.
Okay, so what we can see on stage is like a discipline which is very complete. Like it's physical, like it's technical. It's like it has all of these aspects. Also, like it's not something that we see every day. For someone who would be willing to start to learn and do these kind of things, what would you suggest?
Well, the first thing you should do is, train to get comfortable with the ball. So juggling is always a good start. But you can also get in touch with me, so I can pinpoint you to the right direction on how to start and which tricks might be easiest to start with. So you can get in touch with me on Instagram or Facebook or whatever.
Where can people train with you then?
Outside. It's an urban sport, so it can be done anywhere. Our slogan is all you need is a ball, so you can do it wherever you want to. You can do it on the streets, in a hall. When I was studying in Munich, for example, and I didn't have a hall in winter to train, I was training in the metro station. So yeah, it's possible to do it wherever you want.
Okay, and what you showed on stage is pretty impressive. How long does it take for someone to reach that level? And how much you train per week to reach that level?
To get to that level, it depends, because when I started doing freestyle, the tricks were not there yet as they are today. So it was a slower progress to get to a certain level because you didn't know which way to go or which tricks to train. So nowadays, when somebody starts to train freestyle, they see all of these tricks that exist already, and they know that these tricks are possible. So they can just look at the tricks and try as many times until they get that trick. But when we started, those tricks didn't exist yet. So yeah, we kind of had to find our own, create all the tricks that exist nowadays, and therefore the progress was a lot slower.
So
but
it's a solo sport, but a very cooperative process for.
Yeah.
Okay.
Yeah, I mean, there's communities all around the world who do this kind of sport or expression. So yeah, just find the people who do it in your country, and you can get started if you want to.
Sven, how many freestyle footballers do you know?
Oof, plenty. You mean in Luxembourg or around the world?
Well, yeah, like so. We'll start with so there are How many are there? How many do you know of in Luxembourg?
In Luxembourg, we have a very small community of around 8 people, which varies all the time. There's some people who start, some people who have other priorities, and they change their vision on what they want to do. But around the world, I don't know, hundreds of freestylers.
Where were you when you first came across freestyle football? At university or?
I was here in Luxembourg. I don't know, just minding my own business, playing football in a club, and I found videos of other freestylers on the internet, and that's how I got into it.
Okay. Thank you, Sven.
Thank you for having me. It was a pleasure.
Yeah. I don't know. Sven, does Sven get a goodie bag?
I think he should.
The 12th project today is by Rodion Zaychikov, whose research aim is to find the best material and the optimal printing conditions for 3D printed model rockets.
Hallo, ich heiße Rodion und ich möchte später Modellraketeningenieur werden. Und heute stelle ich euch vor Materialien und Produktionsparameter für 3D-Drucker, Antriebssysteme. Modellraketen werden meistens aus Karton, Sperrholz und Plastik hergestellt. Jedoch in diesem Experiment verwenden wir 3D-Druckermaterialien, um die Raketen zu drucken. Eine Modellrakete fliegt folgendes. Sie startet, dann beginnt sie mit der angetriebenen Flugphase. Nachher folgt die unangetriebene Flugphase. Das heißt, sie fliegt ohne Treibladung weiter. Und dann folgt der Höhenpunkt. Nach dem Höhenpunkt wird die Ausstoßladung aktiviert. Und da wird der Nasenkegel der Rakete, also die Spitze, von der Rakete getrennt, auf welcher der Fallschirm befestigt ist. Und die Rakete kommt dann sicher runter mit dem Fallschirm. Ein Modellraketenmotor funktioniert so, er wird angezündet und dann brennt das Treibstoff und dann kommt die Vorausstoßladung, dann brennt die Treibladung nicht mehr und aus der Rakete kommt Dampf aus unten, damit man sie besser sehen kann. Und dann folgt die Ausstoßladung, welche den Nasenkegel von der Rakete trennt. Und auf dem Nasenkegel ist der Fallschirm befestigt. Für dieses Experiment haben wir PLA, TPLA, PP, TPU 59, PTG und ABS-Materialien verwendet. Dafür haben wir 10% Infill genutzt. Also Infill ist das, was im Modell drin ist. Also im Slicer wird das Modell hohl importiert und dann kann man die Füllung bestimmen. Also das PP-Material war ungeeignet für die Raketen, da es keine Stützen drücken könnte und dafür könnten wir die Rakete mal nicht drücken. Das PLA-Material verformte sich im Flug und deshalb ist es kein gutes Material, um verwendet zu werden. Die ABS-Rakete war zu leicht und flog daher instabil und es könnte gefährlich sein, dafür sollte man sie nicht nochmal starten. Die PTG-Rakete explodierte, weil sie war nicht genug robust, um das Motor auszustehen. Und dann TPU 59 ist absolut für Modellraketen ungeeignet, da es sehr flexibel ist. Für Modellraketen ist nur 10% und 20% Infill geeignet und nur TPLA geeignet, weil das Material ist sehr leicht und wenn wir das Material genutzt haben, flog die Rakete sehr hoch und stabil und hatte gar keine Verformungen nach dem Flug. Und ABS, man könnte 10%, haben wir auch 10% genutzt und die Rakete war nicht stabil, weil nicht genug Infill im Nasenkegel war. Das heißt, dass der Nasenkegel nicht schwer genug war und die Rakete instabil flog. Weil wenn man den Nasenkegel mehr Infill macht, dann wird es schwer und der Schwerpunkt wird nach vorne platziert und die Rakete wird mehr stabil. Und das war's.
Want to have further insights into Agrima and Barbara's innovative idea for a more sustainable future? Well, then let's invite Agrima back for a brief exchange.
Hello, so thank you for coming here. We just wanted to have a small quick word because like you were supposed to come as a tandem and that you were alone on the stage, so like can you tell me a bit more about that?
Yeah, I feel really bad that my partner Barbara couldn't be here today. I learned today morning that I would be performing alone, but I feel like for such a short notice, that presentation went really well. So.
You did great, so we should say hello to her because she's probably watching right now.
Yeah. Well, then maybe where do you know each other from, you and Barbara?
We're in the same school and we do the same science class, and so we had a similar passion for environmental sciences. So I think doing this project together would have been really, really fun.
How did you come up? How did the inception of the idea happen?
Well, we are really passionate about climate change, and we've been attending so many of the climate change protests that were going on in Luxembourg. And so we realized that we do need a solution to all these problems, and we decided to come up with a structure that solved them.
Yeah. And like with the topic of engineering, would you like to pursue engineering further?
Yeah, I mean, I do remember one of the judges mentioned the engineering of the structure itself, and while that is a bit more complicated, I would like to look much more into it to see how everything works in that structure.
Can we then maybe hope to see you again next year?
Absolutely. Maybe if I'm able to build a structure and get it working to a good amount, absolutely.
That sounds very good. And then about the project itself, can you tell us a bit more about the biggest challenge that you came across when actually developing the concept? And
Well, the biggest challenge was maybe adapting it to different environments, because since it's an environmentally conscious project, you have to be able to make it work for different weather environments. And so finding a structure that worked for very dry and like windy environments as well as sunny environments was the biggest challenge.
Okay.
And what was it like working together as a team and with all your other responsibilities and schoolwork?
Yeah, it was a challenge finding a balance between working on the project and doing schoolwork, but I think because we worked together very well, we were able to get all the work done in time.
How, another slightly other different topic, how did you find out about the Young Scientist contest?
Oh, well, I heard a lot of people talking about it in our school, and since me and Barbara were both passionate about this topic, we decided why not give it a go.
How did you take first contact with the association?
Actually, our teacher mentioned it to us, and so I think I'm glad he did, because otherwise we wouldn't be here right now. And so from there, it kind of snowballed on to become where we are now.
On the same topic, then I would like to ask you, if you seem to be willing to come back next year, what would be your advice on people willing to jump in for next year?
Ooh, I mean, I think you might want to figure out the tiny details of your project, because in the end, they do impact a lot on the bigger picture. And so if you have the small details figured out, I think it would be much easier to explain it on stage and take your time.
Okay. Thanks a lot for your help.
Thank you for having
Thanks.
me.
We've got a little goodie bag.
Our next Jonk Fuerscher, Michel Speicher, Niels Huberti, and Philippe Marthe come from the Lycée Hermesinde and present us their project AD3N, Autonomous Defibrillator Distributing Drone Network. In this project, our three Jonk Fuerscher wanted to help people in the case of heart failure. To that end, they developed a prototype of a drone that could help in such a situation.
Hallo, wir sind Michael, Philipp und Nils und wir präsentieren euch heute das Projekt AIDEN, ein Projekt, das Leben rettet.
An dieser Stelle wollten wir dem Institut SNT der Uni Luxemburg danken, da sie uns ermöglicht haben, unser Projekt zu finanzieren. Sie haben den Prototypen unseres Projektes vollständig finanziert. Nach einem Praktikum an der Uni Luxemburg, in dem wir unsere Kenntnisse in der Drohnenentwicklung gesammelt haben, überlegten wir über den Nutzen von Drohnen im Alltag. Anschließend stellten wir uns die Frage, ob sich der Einsatz von Drohnen im Rettungsdienst, speziell beim Transport von Defibrillatoren, lohnen würde. Hierzu schrieben wir eine Recherche- und Analysearbeit, auf der unser Konzept aufbaut. Uns ist vor allem dabei aufgefallen, dass ein Patient im Falle eines Herzinfarktes fast vollständig vom Rettungsdienst abhängig ist. Denn öffentliche Defibrillatoren werden laut Statistik fast überhaupt nicht genutzt und Rettungsfahrzeuge sind für diesen Zweck meist viel zu langsam. AIDEN hat das Ziel, Drohnen als schnelles Netzwerk für Defibrillatoren zu nutzen, sodass man bei Bedarf mittels einer App einen Defibrillator bestellen kann.
Die größte Herausforderung für eine verlustfreie Rettung eines Herzinfarktes ist die Zeit. Denn bereits nach 3 Minuten treten die ersten irreversiblen Gehirnschäden auf. Deswegen sollte man schnellstmöglich mit einer Herzdruckmassage anfangen und auch einen Defibrillator benutzen. Rettungsfahrzeuge treten erstmals nach 10 bis 15 Minuten auf. Unser Konzept sieht daher vor, mehrere Standpunkte zu benutzen, auf denen leistungsstarke Drohnen platziert sind, die diese Defibrillatoren zum Ort des Geschehens bringen können. Also damit die Zeit drastisch verkürzt wird. Ein großer Vorteil von Drohnen ist, dass sie nicht auf das Straßennetz angewiesen sind und direktere Wege zum Einsatzort haben. Auf dieser Grafik kann man sehen, dass die Anzahl der benötigten Standpunkte invers proportional zum Quadrat der Reichweite einer Drohne ist. Die Reichweite einer Drohne hängt der von ihr zur Verfügung stehenden Flugzeit ab und wie schnell sie ist. Um die Flugzeit zu ermitteln, muss man von den insgesamt zur Verfügung stehenden 3 Minuten die Reaktionszeit des Benutzers, die Start- und Landephase abziehen. So bleiben etwa 100 Sekunden übrig. Bei einer realistischen Geschwindigkeit von 75 Stundenkilometern hat die Drohne somit eine Reichweite von 2 Kilometern und man würde 200 solcher Standorte für das Land Luxemburg benötigen. Unser Konzept sieht zusätzlich vor, eine App zu benutzen, mit der man eine Drohne bestellen kann, wenn man sie benötigt. Die App ermittelt die Standortdaten des Mobilgerätes und gibt diese weiter an die Drohne. Wie bereits erwähnt, haben wir einen Prototypen gebaut. Es handelt sich hierbei um einen Quadcopter, der auf hohe Nutzlast und Geschwindigkeit ausgelegt ist. Ein QAV5 Nano Flugcomputer steuert die Motoren und sorgt dafür, dass die Drohne zum richtigen Standort gelangt. Dieser bekommt der Flugcomputer von einem Raspberry Pi Modell 3B Plus mitgeteilt, an dem ein SIM-Modul angeschlossen ist.
Unsere bisherigen Erfolge, die wir beim Umsetzen dieses Projektes verzeichnen konnten, sind zum Beispiel das Durchführen manueller und autonom gesteuerter Testflüge im Freien. Hierbei haben wir verschiedene Techniken, wie zum Beispiel Geofencing benutzt. Bei solchen Testflügen wurden bei nur 70% der möglichen Leistung dieser Drohne über 85 km/h erreicht und die Steigerate der Drohne betrag über 9 Meter die Sekunde. Außerdem ist es uns gelungen, mit dem Bordcomputer, also ein Raspberry Pi, der auch über ein SIM-Modul verfügt, den Bordcomputer oder den Flugcomputer von QAF sich mit diesem zu verbinden, was dazu führt, dass wir mittels eines selbstgeschriebenen Programmes, wenn wir mit einem Computer Kontakt zum Raspberry Pi haben, diese Drohne kontrollieren können. Dieses Programm wurde mit Python geschrieben, einer Programmiersprache. Und man kann mithilfe des eingebauten SIM-Moduls Textnachrichten, also SMS, empfangen und auslesen. Ja, außerdem, das Flugverhalten dieser Drohne ist sehr gut. Das haben wir festgestellt bei mehreren Testflügen. Sie wiegt in etwa 3 Kilo mit Akku und hat einen Schub von 8 bis 10 Kilo. Das heißt, sie ist wirklich ausgelegt für größere Nutzlast. Das wird allerdings nicht nötig sein, da unser Defibrillator wahrscheinlich nur 400 Gramm wiegen wird. Für die langfristige Entwicklung dieses Projektes haben wir uns einige Ziele gesetzt, die dieses Projekt auf Dauer vorantreiben werden. Wie schon gesagt, momentan arbeiten wir an einer App für Mobiltelefone, welche dem Benutzer die Möglichkeit geben wird, im Falle eines Herzinfarktes, den er bemerkt, also nicht von sich selber wahrscheinlich, aber dann von einer anderen Person, mithilfe dieser App auf einen Knopf zu drücken und dann wird eine Textnachricht, eine SMS wird gesendet, die die Drohne alarmieren soll, also zu sich rufen soll. Das heißt, ja, also die nötige Software existiert bereits auf der Drohne, um solche Textnachrichten zu empfangen. Und ja, das Programm dafür ist noch in Arbeit. Das heißt, in näherer Zukunft wollen wir dazu Testflüge anstellen, wo wir einfach die Drohne rufen mit einem Programm. Außerdem arbeiten wir gerade an einem Konzept zur Hinderniserkennung, Hindernisvermeidung und zur automatischen Landung dieser Drohne. Das wird höchstwahrscheinlich funktionieren mit Hilfe von Kameras und Deep Learning Algorithmen, die die Entfernung zu gewissen Objekten und Hindernissen und auch Hindernisse am Boden erkennen werden. Vielen Dank für Ihre Aufmerksamkeit.
Let's get a deeper insight into Rodion Zaychikov's project and find out why and how he got into sciences.
Danke, dass du hier bei uns bist. Seit wann interessierst du dich für Luft- und Raumfahrttechnik?
Also für Lufttechnik habe ich mich schon seit 6 Jahren interessiert. Und ich probierte so kleine Flugzeuge zu bauen. Sie haben aber nicht geklappt. Sie sind alle abgestürzt immer. Und dann habe ich vor 2 Jahren Wasserraketen begonnen zu bauen, die mit Wasser fliegen. Sie haben auch nicht alle geklappt und jetzt baue ich Modellraketen und sie klappen alle.
Cool, ja. Und du willst dich in Zukunft auch weiterhin damit beschäftigen?
Ja, also auch mit echten Raketen.
Ja.
Also das ist natürlich deine erste Partizipation für den Contest hier. Hast du Lust wiederzukommen nächstes Jahr?
Ja.
Was möchtest du zum Beispiel erweitern mit deinem Projekt oder besser machen? Oder hast du noch neue Ideen für ein neues Projekt?
Ich habe eine neue Idee. Eine zweistufige Wasserrakete mit Fallschirm.
Okay.
Aber ohne Elektronik drin.
Aha.
Also die zweite Stufe habe auch den Fallschirm ganz ohne Elektronik aussucht.
Okay, und warum ohne Elektronik diesmal?
Also weil wenn die Rakete abstürzt, dann geht die auch Elektronik, funktioniert sie dann auch nicht mehr.
Mhm.
Und es ist viel teuer.
Ja.
Und auch es ist einfacher zu bauen. Und wenn man Elektronik einsetzt, muss man auch das sehr lange programmieren. Und diese Rakete, sie wird auch kurz zu bauen. Und ich habe auch eine Webseite. Ich habe sie jetzt gemacht, vor ein paar Wochen. Sie ist aber nicht fertig.
Okay. Okay, wie heißt deine Website, so die Leute können vielleicht das gucken?
Ja, aber sie ist noch nicht fertig.
Okay, okay. Und was am meisten Spaß? Also ist das die Konzeption oder wenn du siehst einfach die Rakete in der Luft?
Also, es ist, es ist sehr aufregend, wenn man eine Rakete startet.
Ja.
Weil, also wenn man eine Rakete, die man sehr lange baut, zum Beispiel ein Jahr, wenn sie runterzufallen beginnt und der Fallschirm nicht aufgeht und dann für 5 Metern von der Erde der Fallschirm aufgeht, dann will man zu der Rakete laufen und sie auffangen, weil man will nicht, dass sie kaputt geht.
Wo startest du die Rakete?
Also im Angelsberg und also auf einem Feld.
Ja. Wo viel Platz ist. Ja. Cool. Ja. Und was sind die nächsten Schritte für dich?
Diese Wasserrakete zu bauen, die große, also und echte Raketen zu bauen. Und auch ein Fallschirmsystem bauen für Wasserraketen, also ohne Elektronik, welche man einstellen kann für bestimmte Zeit, wenn man sie aufdreht und welche auf einem Seil befestigt ist, welche dann also im Boden steckt mit einer Schraube. Wenn die Rakete startet, wird das Mechanismus aktiviert und dann dreht er sich und dann wird der Fallschirm ausgestoßen. Und das will ich auch verkaufen, das System.
Okay.
Cool. Vielen Dank für deine Zeit und dass du hier warst, um uns noch ein bisschen mehr zu erzählen. Und viel Glück auch noch besonders für Sonntag. Da hast du noch mal ein Poster, glaube ich. Ja, cool.
Wir haben den auch schon gemacht.
Ja.
Sehr gut. Dankeschön.
Danke.
The 14th project of a day is by Arnett Day and Punyabalan Sendil Kumar, entitled 2020 for All. Their project aims to help people with visual impairments, and so they developed a glasses prototype. Stay tuned if you want to know about how it works.
Welcome to our project, 2020 for All, created by Arnett Day and
Punyabalan Sendil Kumar.
Helen Keller once said that the only thing worse than being blind is having sight but no vision. That is the reason we have created this project. For people who have vision but no sight, to fully understand and perceive their environment. But more importantly, we created our project so we can make a difference to the visually impaired. But is visual impairity really a problem? Well, according to this statistic, it is. As you can see, the traditional blindness mostly affect the larger countries like India and China, with 8 million and 9 million people suffering from traditional blindness in the said countries. But visual impairity is a growing problem all over the world, with 253 million visually impaired. Out of that, 36 million people being traditionally blind and 217 million people with MSVI, moderate to severe visual impairity. In this statistic itself, Luxembourg has over 1,000 cases of traditional blindness, and it is increasing.
We wanted to know the problems the visually impaired face and wanted to do something about it. We wanted to help them by creating a product. We wanted to make the world a better place for them. Also, we wanted to combine and introduce the idea of echolocation with our device. We hoped that it would help the visually challenged to better perceive their surroundings and allowing them to maneuver around obstacles in their path. Not only did we want to make a product that will help the visually impaired, but also a product that could reach all, regardless of their economic situation.
So, why did we create this project, you may ask? We have a couple reasons for that. Number one is our aim to make a difference in the lives of the visually impaired all over the world. And we hope to spread awareness about our project so that this can be spread to every part of the world, and its benefits can be reaped by the people affected by this. Secondly, we made this project because of our love for innovation, and we wanted to combine new technology with a present problem to create an effective solution. Our project uses echolocation to locate obstacles and warn the user of incoming danger, and we got this idea from a very special animal, the bat. So, after school one day, me and Punya were walking past a park, and suddenly 2 bats screeched very loudly and flew past us with a grace we had never seen before. And we were even more surprised when we realized it was day. We knew bats cannot see very well in the day, and we researched, and this is where we came across the idea of using echolocation. We both discussed, and suddenly we got an idea to utilize this phenomenon in a product and in real-life situations for the visually impaired. In this diagram, you can see how echolocation works. It works by sending sound waves, and the sound waves bounce off an object, and the sound waves return. In this diagram, the bat sends and receives the sound waves and interprets the distance between itself and the object and moves accordingly. Simple yet ingenious. And that is how we got the spark for our project. And here we are in front of you. And here is our project, 2020 for All, which uses a lightweight silicone frame with an inner metal frame to ensure maximum durability and comfort. The electronics box is fitted with 3 ultrasonic distance sensors, which send and receive the sound waves, and an accelerometer which sends a signal to the ultrasonic distance sensor when it should start sending out sound wave, as the motion sensor only works if the user is moving. hence the accelerometer, which can interpret if the user is moving or not. It also uses a motherboard, which controls all of this, and can then activate the speaker when it gets a suitable result, and the speaker will then warn the user of incoming danger.
The glasses have a padding and an opening for the nose to ensure comfort and a perfect fit to the face. The ear and nose padding will be made of soft clothes that prevent ear and nose pain after wearing the product and also prevent allergic reactions from coming forth. A speaker is placed beside the ears so users can receive instructions from the motherboard about any incoming danger in front of them or in their sides. Also, these instructions are spoken at a very low volume to prevent public disturbances.
In conclusion, we hope we can further develop our project using machine learning to interpret what the object is, and we also hope to develop a project where we can get more accurate results over greater distances. We hope we can take our project further and create an impact for the people who our project has been intended for. We also hope we can create awareness about the visually impaired and the challenges they face. But we also hope to eliminate the challenges they face and greatly impact their lives. All inventions stem from a simple idea and passes through multiple phases of modification to attain its full potential. Our work continues, and we hope to take our idea to the next stage of excellence. Thank you.
Would you like to find out more about Michel Speicher, Niels Hubertis, and Philip Mars' innovative idea? Well, we got you covered.
Thank you guys for joining us here now. Maybe first, how do the three of you know each other?
We're in the same class, in the same school, and we have similar interests, so yeah.
Is this the first time that any of you participate in the contest?
Yes, it's the first time.
Okay, cool. Well then maybe, how did you come up with the idea for this?
So, first of all, we're all very interested in robotics and electronics and stuff. At our school, we have to write a paper every year, and last year we had to do one with a team of around three people. Before we did an internship at the University of Luxembourg, where we also built a drone. So we started talking about the use of drones in everyday life. And then we came to the conclusion that we could write something about drones in first aid, and eventually we came to defibrillators, transporting them. Our contact from the university proposed to us that we could actually build this prototype and develop this project, that they would finance it. And so we said yes. That was a bit over a year ago, and since then we're working on this.
There was like details in your presentations about like how it works and like what's at stake behind that. One thing I noticed though was basically you have a plan, and we see like for the questions that the people didn't see on screen, you were talking about your long-term goals for that. How far do you want to push this like development, and like where do you want to go in the future with that?
Yeah, I think we want to go as far as possible with our time. We're graduating next year, but we'll keep working throughout that. And we have to look upon which universities we are going to, and if we can keep working together on this project. Yes.
Okay, you want really to put that to the end, right? It's not just a fun project.
But in the end, it's about the proof of concept that this actually works. We want to push it as far as possible with the proof of what works, what doesn't work. So in the end, maybe we can show it to someone who actually will do something like this on a larger scale.
Yes.
It's first and foremost about proof of concept.
Okay, I heard as well that you have a big interest in coming back next year.
Yes,
for
really.
the contest.
Yeah.
So, if you come next year, what would be changed? Do you think? What do you intend to develop in the meantime?
So as said before, we're currently working on obstacle avoidance,
Yes.
And automatic landing. Also, shortly we will do our first test flight where we will only use an SMS to contact the drone to fly to a certain position. So yeah, well, hopefully when we will come back next year, these goals will be reached. Yeah, that would be our wish.
I understand.
Yes, but it has to be said that this area of development is much more complex than what we did now, and yeah, progress is more slow and it's difficult to get going in this area because obstacle avoidance, for example, is a huge problem for drone developers. So we're not expecting to find a solution to that just in a week. But yeah, we'll get as far as possible. And
we give you 2 weeks. It's okay.
Yeah, we're making good advancements. So
I mean, well, we're giving our best, but none of us. Well, I mean, we don't have degrees in computer science or something, so we're just teaching ourselves basically to do this.
Achieved that, you know what I mean. So yeah.
What was the most fun part of working on this? Constructing the machine, or doing the presentation just now, or talking to the judges?
The test flights.
Yeah, they're great. I mean, you can
see if it now works and
does it work? Yeah, does it work?
As we've thought it would be.
Yeah. Does it work? Does it?
Did it
not
immediately work?
Sorry.
Did it immediately work?
No.
We had like lots and lots of setbacks. Like sometimes for weeks there were huge software issues that we had to resolve first. Yeah, I mean until this thing could fly, it took a while. So.
Yeah, it's a lot of trial and error, but it has to be said it has an aspect of a big children's toy. So yeah, it's fun to fly it.
So now it works, but like if you had so much tests, like do you think there was a point where it was almost discouraging and like you persevered, or it was still fun all along?
Well, there were some moments where well they were less fun because if you're stuck for hours on software that's undocumented and you have to go through half the internet to find a solution, all that at some point it can be a bit annoying, but in the end we just want to achieve that certain goal. We want to work on the project, which is also fun. So even if there are some obstacles, they will not stop us from going further.
What in-flight obstacles did you encounter? So when the machine being in the air, what's
the main problem in terms of obstacle avoidance and?
So this is also a part of the concept, but you want to use open flight areas, and that would also be achieved when we fly in reservated zones that are only used by drones. So no other aircraft and no trees or other obstacles that are that high, because as said, obstacle avoidance is a huge problem, especially at high speeds, and you just want to have a clear way, just as cars use a highway to go fast, because you just don't want to have any obstacles, because reaction time is super fast at those speeds, because we would go as fast as a car goes on the highway.
And maybe finally, in terms of all the scope of development, like if you had to recommend the contest to someone else for next year, what would you recommend them to? Do you have any advice for newcomers?
Use something useful come up with a useful idea.
Don't be afraid to try, and I mean, if you make a mistake, it doesn't matter as long as you try and continue. Well, at some point you will arrive at something that you can be proud of.
Yeah, and
also you should be proud of.
If it takes a year longer, it takes a year longer.
Thanks a lot for your help.
Yes, thank you very much, and good luck for the rest of the contest, especially for Sunday.
Thank you.
Thank you.
Our next participant, Leo Gomez, really enjoyed working on his project called Bei welcher Temperatur gibt es die größte Cola-Mentos-Fontäne? Experimente zur Temperaturabhängigkeit der Cola-Mentos-Reaktion. As the project title already suggests, Leo tried to find the optimal temperature to produce the best, or rather most explosive, Cola-Mentos reaction. The floor is yours.
Also, guten Abend miteinander, Mittag besser gesagt. Ich stelle euch heute mein Projekt vor, die Cola-Mentos-Reaktion mit der Hitzenabhängigkeit. Warum habe ich das ausgewählt, um es auszuführen? Als ich ein Kind war, also kleiner war, habe ich gern solche Sachen gesehen, hat mich immer sehr fasziniert, wie das halt dann hochgespult ist und alles. Und ich habe es dann mehrmals versucht und ja, es hat nicht immer wirklich funktioniert. Und ja, dann habe ich mir jetzt gedacht, da ich schon die Möglichkeit hätte, das dann auch zu experimentieren. Und dabei habe ich dann herausgefunden, dass dann mit vielleicht mal einer anderen Temperatur eine andere Reaktion auskommt. Und ja, also, ja. Also Vermutungen. Meine Vermutung war, desto höher die Temperatur, desto besser die Reaktion von der Cola-Mentos. Warum? Wenn die Getränke erwärmt sind, dann zirkulieren die Moleküle mehr, also schneller. So, Cola Light funktioniert am besten, da in der Cola Light Aspartam drin ist, der mit dem Arabicum auch dann reagiert. Und Cola Light hat dann das Aspartam, weil das dann auch, also ich habe es ausgewählt, weil es Aspartam hat und das dann auch am besten funktioniert. So. Versuch 1. Da ist es nicht wirklich gut gelaufen, wie ihr sehen könnt. Ja. Wie ihr sehen könnt, ist nicht wirklich einfach zu treffen. Da haben sie nicht alle funktioniert, wie man da sieht. Der eine ist schon am Sprudeln, während der andere erst hochgeht mit einer höheren Temperatur. Versuch 2. Da haben wir erst geprobt. Und ja, da ist dann rausgekommen. So. Versuch 3. Das ist dann bei mir zu Hause. Und da lasse ich sie rein. Bei der von 90 Grad, das ist dann jetzt die von meiner Seite aus gesehen die rechte. Die sprudelt nicht mehr, weil das Kohlendioxid schon längst raus ist. Man braucht ja Kohlendioxid, damit das Ganze hochgeht. So, wenn man jetzt sieht. Jetzt hat man gesehen, dass die mit 80 Grad besser funktioniert hat als der Rest. Nur bei der 90 Grad hat es nicht wirklich gut funktioniert. Warum? Kohlendioxid war raus und die Flasche hat sich ganz verzogen. Das heißt, größtenteils war die Cola auch nur noch im Topf, wo man es dann reingestellt hat. Beobachtung, die mit 5 Grad, die hat dann halt nicht wirklich gut gesprudelt, von 20 gar nicht, 40 etwas mehr wie die von 20, dann die 60 Grad, hat auch nicht direkt funktioniert. Die 90 Grad, die hat sehr gut funktioniert. Dann unten die von 5 Grad, die ist dann später aufgegangen, wie die von 90 auf dem oberen Bild. Und dann die 90, die ist dann schon längst fertig. So, hier sieht man nochmal Standbilder. Die von 40 Grad geht hoch. Jedoch sieht man, wenn man die zwei Bilder vergleicht, sind sie nicht gleich hoch. Das heißt, der von 90 Grad ist etwas höher. Es war mir nicht möglich, diese gleichzeitig in die Flaschen zu machen, wegen den Zielen und alles. Das ist nicht so ganz evident. Ergebnis, die von 90 Grad sprudelt am höchsten. Weil, also es funktioniert nicht besser mit 60, also 60 und 90 ist ungefähr dieselbe Reaktion. Das heißt, man müsste nicht unbedingt auf 60 hitzen. also nicht auf 90 hitzen, sondern man kann sie auch auf 60 hitzen dann halt, also nicht auf 90, sondern auf 60 hitzen. Und ja, bei welcher Temperatur gibt es denn jetzt die größte, war jetzt meine Frage. Bei der größten gibt es von 60 auf 90 ist fast kein Unterschied mehr, aber alles unter 60 gibt schon Unterschied. Das heißt, 5 Grad war ziemlich wenig und dann bei 60 Grad war schon etwas mehr. Man braucht CO2, das Kohlendioxid so gesagt, braucht man, damit das Ganze überhaupt hochspult. So. Die Reaktion besteht dann halt aus Aspartam und Arabicum. Die zwei verbinden sich und das wird dann eine chemische Reaktion und das sprudelt hoch mit dem CO2. Und das war's dann auch schon.
Remember Arnie Day and Punyabalan Senthil Kumar with their 2020 for All project? Well, before we have a small break, let's get to know them a bit better. And afterwards, we will have a small chat with Leo Gomez to find out more about him.
Okay. Thank you very much for joining us here for another interview. It's amazing how you turned a real-life experience into an idea to help others. How did you get the inspiration for your project?
As we said before, me and Punya were walking like after school one day in a park in Pittsburgh, and we saw 2 bats, and like they screeched past us, and we were amazed. So, like they were flying at such gracefulness, but we knew like they cannot see very well in the daytime because they're bats and they have like bad eyesight. So we researched and we found this phenomenon called echolocation, and that is how we found the idea basically for our product.
So from looking at bats.
Yes.
Yeah. And how did the idea develop into building echolocation into glasses?
It took a couple months. So like for the first month, we were just planning and designing our product in Tinkercad and in Written. And then we found out about Makerspace here in Geeseknapschen. And so we decided to go there to see what, like, if we could, like, how we could develop our product. And we found out that we could. So we started working on our product, and here it is.
You actually brought it on the table here. Can you show us a tiny bit, like, and tell us what was the biggest challenge in the construction, actually?
So here are 3 of the ultrasonic distance sensors used for echolocation.
Okay.
These 3, and this one right here, this is the accelerometer, which is used for motion detection, and this is the motherboard where all the information go into and process. And if there is motion, the accelerometer will send a pulse to the motherboard, and the motherboard will send pulses to these 3 ultrasonic distance sensors, and the sensors will perform echolocation and collect the data of the closest object and how far the closest object distance is and those stuff, and send it back to the motherboard. And if an object is within 100 centimeters of the glasses, it will the motherboard will send a pulse about the object's distance and the direction to the speaker, and the speaker will say danger on the right or the left or up ahead, and the distance from the glasses to the object.
Okay. And one of the main problems in building this was actually 3D printing the model, because we got the measurements wrong like at least 3 times, and we have 3 different models of the same thing. So yeah, the production was like a production of the actual glasses was like a problem, and obviously putting it in the glasses was also a bit of a problem, but that wasn't so much of a problem.
Do you plan on coming back next year?
Yes, we plan on coming back next year with a bit more sophisticated product, with a silicone and a metal inner frame, with a silicone outer frame and a metal inner frame, and we hope to like put the devices on the inside so it won't show, and yeah.
Okay.
Did you yourself test the glasses?
Yes, we did.
Walk around blind and. How often did you get a message through the?
It depends. Like if there's an object, say like for this example, this table, the glasses would detect that and say, say that there's a danger on. Like depends where you are. If you were on the left of the table, it would say danger to the left, and yeah, that's how it works basically.
The messages would arrive every second.
Yeah, okay.
After each message is finished, that would take approximately 3 to 4 seconds. The next message will arrive.
Yeah. Would that have an impact on how quickly you are allowed to walk?
No, because it just keep on recalculating the distance between the user and the object.
Okay. Yeah, cool. Well, thank you very much for joining us here, and good luck with the rest of the competition with Saturday and the posters and so on. Yeah.
Thank you.
Thank you.
Thank you.
Then we Wenger Spruch So,
Doppelt mal egal,
Deutsch oder Leo, schön, dass du hier bist. Wie bist du auf deine Projektidee gekommen?
Also als ich kleiner war, habe ich immer auf sozialen Netzwerken gesehen, zum Beispiel YouTube, dass die Leute dabei Spaß hatten, sich das aufzubauen und dann die Mentos in die Cola fallen zu lassen. Ich habe das dann auch manchmal versucht, war meine Mutter nicht immer sehr froh damit. Und ja, jetzt hab ich mir gedacht, das könnte vielleicht etwas mit den Temperaturen zu tun haben, weil es bei mir nicht immer funktioniert hat und bei den anderen hat es immer sehr gut funktioniert. Ja. Und ja, das Resultat ist, es hat etwas mit den Temperaturen zu tun.
Okay. Und wie hast du dann die Temperatur kontrolliert?
Die Temperatur habe ich mit einem normalen Thermometer kontrolliert, mit einem Alkoholthermometer und mit einem
Flasche auf, Thermometer rein.
Und dann in den Topf mit warmem Wasser gestellt, genau.
Also ehrlich zu sagen, Leo, wenn ich habe die Liste mit Projekten gesehen und ich habe deinen Titel gesehen, ich dachte, ja endlich jemand hat den Mut, diesen Projekt zu nehmen hier. Weil das war mein erster Gedanke bei den Young Scientists, diesen ganzen Experiment zu machen und etwas ein bisschen so, hat das Spaß gemacht, weil das ist relativ wichtig hier.
Ja, mir hat es eigentlich Spaß gemacht. Ich würde es nochmal tun, vielleicht mit einem anderen Experiment, aber es hat mir wirklich schon sehr gefallen.
Ja. Und wie war es, auf dem Podium zu stehen und die Präsentation zu geben und nachher mit dem Jury zu sprechen?
Also am Anfang war ich etwas nervös, hat etwas gezittert, aber danach ist es wieder gut. Ich habe auch schon etwas die Gewohnheit. Ich habe auch schon in verschiedenen Theatern dann mitgespielt gehabt und ja, das hat mir dann halt den Mut gegeben, da mitzumachen.
Ja.
Und könnte man also auf die Präsentation deinen ganzen Prozess sehen? So, das ist nicht nur ein Spaßprojekt eigentlich, aber du hast relativ viel gelernt. Was war dein der größte Lernpunkt da mit dem ganzen Prozess?
Zuerst mal die Erwärmung, mit wie viel Grad sich dann halt auch die Cola, dann wie sagt man das? Wie soll ich das erklären? Das Kohlendioxid aus der Flasche verfliegt mit einer verschiedenen Zeit oder mit einer verschiedenen Hitze. Bei 90 Grad ist es dann halt so, dass sie dann verdampft ist und dann schrumpft auch die Flasche, weil es dann so warm war. Das heißt, sie hat sich komplett verzogen. Und ja, das hat mich sehr, sehr fasziniert und ich habe dann auch daraus gelernt. Und ja.
War das, was am überraschendsten war bei den Resultaten?
Ja, das war das Überraschendste. Also meine Vermutung war dann halt richtig. Ich habe mir schon gedacht, dass etwas mit den Temperaturen zu tun hat, weil die Moleküle schneller zirkulieren, wenn das Getränk etwas wärmer ist.
Cool.
Also wenn ich möchte eine größte Cola-Bombe Mentos machen, also zu Hause, also macht das auch einen Unterschied, wenn ich Coca-Cola Zero nehme oder Coca-Cola normal oder?
Das macht schon einen Unterschied. Das ist irgendein Stoff, ich weiß jetzt nicht mehr, wie der heißt, aber ist schon ein Unterschied, weil etwas anderes drin ist.
Okay.
Das heißt, die Cola Light ist schon besser als die normale Cola.
Okay. Hast du Lust wiederzukommen nächstes Jahr mit einem neuen Projekt?
Ja, es hat mir eigentlich sehr viel Spaß gemacht und nochmal zurückkommen will ich auf jeden Fall. Und ja.
Hast du schon eine Idee vielleicht?
Naja, eigentlich noch nicht. Das kommt mir noch in den nächsten Monaten.
Sehr gut.
Leo, vielen Dank, dass du da warst und auch noch viel Spaß und viel Glück für Sonntag. Die Präsentation von dem Poster und alles.
Okay, vielen Dank.
The next project of this contest is called Feasibility of Converting from Uranium to Thorium Power Plants, as opposed to constructing new power plants. The young scientist behind this project is also a returning participant, Alina Liedke. Please welcome Alina on stage.
So, hello, my name is Alina Liedke, and I chose to do my project on the feasibility of converting uranium power plants to thorium-fueled ones. So first, a bit of background information. So the main way that nuclear energy is produced is through nuclear fission, which is the splitting of an atomic nucleus into two smaller ones, and this releases substantial energy. Mainly, this energy comes from the energy needed to hold the atom together. This is also known as the nuclear force. So most power plants use uranium-235 as their fuel element, or fuel isotope. So when a neutron collides with uranium-235, it causes it to become uranium-236. And this is a highly unstable isotope, so it splits into two smaller nuclei, and this also releases 2 or 3 neutrons, and these neutrons go on to collide with other uranium-235 isotopes, and this is called a nuclear chain reaction. And it's very important that this reaction can be controlled. If not, it'll get out of hand and could be very dangerous. So this is done through control rods. So in the bottom left, you can see the uranium-235 isotope and a neutron. And then it hits, and then it becomes uranium-236, and then it splits into, in this case, krypton and barium, releasing 3 neutrons. And then on the right, you can see a nuclear chain reaction. So in my presentation, I'll talk about one specific type of power plant. However, there are several different others. So I'll talk about light water reactors, which are nuclear reactors that use regular H2O as a moderator and a coolant. And what this means is it slows down the neutrons to the correct speed for fission. So this is done by the neutron colliding with several different water molecules, and because each collision is inelastic, it'll slowly lose more and more energy. And a coolant is to regulate and reduce the temperature of the reaction. So on the left, you can see a pressurized water reactor. So the coolant would be held in the yellow-orange cycle, and then the coolant would absorb the heat energy produced by the fission and would then be carried outside the reactor vessel, and then the heat would be transferred to a different cycle, which is the light blue, dark blue, and then the water outside will be able to boil to become steam, which then in turn spins a turbine and then spins a generator. And then that steam is then condensed back into water so that the cycle continues. So Cattenom actually has 4 of these, and it isn't too far from here. And another type of reactor is just a boiling water reactor, where everything's in one cycle, but a pressurized water reactor has 2, so that the water in the reactor vessel isn't contaminated, can't contaminate the steam outside. So what exactly is thorium? It's a radioactive metal solid at room temperature with a atomic number of 90, just 2 less than uranium, and has an atomic mass of 232. So it's fertile, meaning it can undergo nuclear fission as long as it is in contact with a fissile material such as plutonium or uranium. Also, upon absorbing a neutron, it'll become thorium-233, which then undergoes beta decay and becomes protactinium-233, which then undergoes beta decay again, and then you get uranium-233, which is also a very excellent fissile fuel material, which can be used in other nuclear power plants. So world monazite resources, which are the world phosphate mineral that contains thorium, are estimated to be about 16 million. So some advantages and disadvantages is that thorium-232 is the only naturally occurring isotope of the element, whereas uranium has 3 isotopes, uranium-238, 235, and 234. And this is crucial because when uranium ore is mined, you only get 0.7% of the useful isotope of uranium. So this will then need to undergo further enrichment, whereas when thorium is mined, you'll immediately get thorium-232, which is already useful. It is also more naturally abundant than uranium, almost 3 times. It's safer because you can easily drain the fissile fuel material from the thorium, and then the reaction will stop because thorium itself is fertile. So it could be paired with plutonium as the fissile fuel material so that the plutonium is recycled from other nuclear reactors that use uranium. However, a disadvantage is that there's a severe lack of research and development in this field, so there's a low incentive to increase investments in this area. And another investment would have to be in the fissile fuel material used along with thorium. So as of right now, the main feasible power plant would be light water reactors or pressurized water reactors. However, many companies are more focused on implementing a net zero production of plutonium, where they use plutonium from other uranium power plants to be used with thorium so that it's recycled. So there are 3 methods. The first one is thorium additive, where it's 5 to 10% of thorium in a uranium fuel. And this is just to improve the performance of the fuel. And it's mainly used to gain experience with the element before it is fully implemented. The second one is thorium mixed oxide fuel, and this would use plutonium as the fissile material to go along with thorium. And then the last one is a thorium-uranium cycle, and this would be a complete replacement of the uranium cycle. However, again, there will be more further research needed into this. And while I was doing research, I came across a Norwegian company called Thor Energy, and they're developing and testing a thorium fuel cycle to be used in existing reactors rather than reconstructing new ones, because this would be a huge investment. So their fuel designs are supposedly compatible with 90% of all existing reactors. 90% of these are light water reactors, as I mentioned earlier. And they promote the use of plutonium as the fuel, as a fissile fuel material to go along with thorium. And so they use the 3 methods I mentioned earlier. However, they started with thorium additives in 2018, and they intend to continue with thorium mixed oxide fuel, and then from there, the thorium-uranium cycle in the future. So thorium seems like a very innovative method to produce nuclear energy in a sustainable and environmentally friendly way. However, the technology and knowledge of thorium fuel is very immature and will need further research and development before it becomes commercially viable. Thank you for listening.
Before our next project, let's hear some words of encouragement from the former Jonk Fuerscher.
Moin, mein Name ist Elis und ich bin mittlerweile 10 Jahre für die allererste Kehr beim Jonk Fuerscher Konkurs gemacht. Es war damals wirklich eine extrem flotte Erfahrung für mich, die mir aber auch für die Zukunft ganz viel mit auf den Weg gehen hat. Und genau das wünsche ich euch auch. Ich wünsche euch ganz viel Spaß, ich strecke nicht Daumen und ich freue mich auf das Projekt.
Liebe Jonk Fuerscher, lo ist es soweit. Endlich könnt ihr die Früchte von ihrer Arbeit präsentieren und ihr die Frage von der Jury stellen. Seid ihr schon abgeregt? Ich war ungefähr 24 Jahre auf ihrer Platz und ich muss sagen, das hat mein Leben komplett verändert. Ich gehe heute wahrscheinlich nicht hier sitzen am Naturmuseum und mit Fossilien forschen. Ich wünsche euch auf alle Fälle für den Konkurs alles Gutes, viel Spaß, viele neue Bekanntschaften und ich bin mir sicher, wenn das ein paar Jahre auf den Moment zurückblickt, dann wird er so ein Doge auf die Weiche gestellt. Toi, toi, toi.
Hey, ich bin Dylan. Und ich bin schon so bei Jonk Fuerscher mitgemacht, 2018 und 2019. Und das Jahr sind ich als Volontär dabei. Und für allem das Jahr ist es ganz schwer. Also wünsche ich jedem Verein, der mitmacht, viel Courage und viel Glück.
Moin, ich bin Dr. Hoffmann. Und ich habe 30 Jahre mit dem Jan Baden in Braille-Converter-System developiert für die Jonk Fuerscher. Und ich bin halt Urologe, ich arbeite noch an der Recherche, an der Immunologie. Und was wichtig ist in der Recherche, ist, dass die muss anders denken. Die sollte crazy sein, think out of the box. Die muss viel lesen, die muss Ich lese an der Allergie, ich lese Gynäkologie, Medizin, internen Auswärtigen und Zentfeld, Höhlenauswärtigen, hier kriegen du. Das ist wieder eine Fluchtrecherche. Die Fluchtleiter auch so dran, weil ich nicht versuche, dass das Sascha Slowhai bei mir nur wendet, den als geholfen hat, auch als System zu validieren. Und ich denke, Sascha kann also eine ganz gute Message geben, was an das geschieht, das auch für Blatt Leute. Und ich muss Sascha schwätzen.
So, der Paul hat schon erwähnt, wir von 30 Jahren ein Braille-Display oder gouf mir präsentiert von zwei Lützebäuer Jonk Fuerscher. Und das war schon eine Innovation, gouf natürlich international schon die Bemühungen für eine Braille-Zeile zu entwickeln. Heute ist das quasi von einer Braille-Zeile, natürlich damals hat man so kleine Modul mit 6 Punkten, heute haben wir da 80 an der Majorität und gibt sogar auch Braille-Zeilen, die 4-5 Zeilen mat neen hunn, die auch so grafisch Durchstellungen hunn, dat also alles weiterentwickelt gin. Und da sind auch schon beim Punkt, die letzten 30 Jahre ist ganz viel an der Forschung geschieht. Für Eis, also für mich, wie eine blinde Person, hat dadurch natürlich enorm profitiert. Wir haben heute Hilfsmittel, die Eisen autonom leben, ermöglichen Breitzeige, das Möglichkeit, Computer zu lesen. Sprache, es gab Leser, alles 4, was wir Computer fanden. Voice-over iPhone oder auch Talks Google Handy oder wo auch immer, die geben als Möglichkeiten für autonom mit dem Handy zu schaffen, Bankoperationen zu machen, alles Sachen, die durch die Forschung entwickelt sind. Dann kann ich noch davon der Schwätze von den Luten, die piepsen, das alles zurückzuführen auf Leute, die irgendwann keine Idee hatten, die geforscht haben, die recherchiert haben und die es entwickelt haben. Und das ist das, was heute flott ist. Und dafür der wir noch nicht abhalten, weil es geht immer weiter. Wir brauchen immer noch neue Hilfsmittel, neue Innovationen für unseren Weg können zu gehen. Ich benutze seit 17 Jahren einen blinde Feierhund. Ich bin also viel vorgestellt, ob es da noch möglich wäre, für irgendwann ein Jahr sozusagen einen blinden Feierroboter zu entwickeln. Wir sind gespannt, ob es selber mal irgendwann da gibt. Vielleicht ist ja von der Lützebäuer Novus Forscher bereit, für einen zu gucken, ob es eine Feiermaschine gibt, die uns dann den Weg weist, wo man dann irgendwie die weiße Bengel müssen rausholen, Apotten auftasten, bevor wir unseren Weg finden. Wer weiß, was da alles geschieht. Forschung ist wichtig, bleibt dran, weil sie hilft, viele Leute weiterzukommen und eine bessere Welt zu kreieren. Aber wie der Paul auch schon gesagt hat, freidenken, open denken, und sich etwas trauen.
Hallo, ich bin Charles, ich bin bei Jonk Fuerscher 2011 und 2012 mitgemacht. Und ich wünsche dir ganz viel Spaß dieses Weekend beim Konkurs. Es sieht super, dass der so weit gepackt hat. Und ich drücke dir ganz fest Daumen. Bonne Chance.
Lief Jonk Fuerscher, dir wollt erkennen, was Welt am innersten zusammenhält. Ich weiß, mit Corona ist es nicht einfach und trotzdem muss ihr Ziel erreicht. Macht weiter so, bleibt am Ball und genießt die Erfahrungen, die ihr machen werdet. Ich wünsche viel Spaß und alles Gutes dieses Jahr.
Passt auf euch auf und stay safe. Trotz dieser komischen Zeit wünsche ich euch viel Spaß bei der Umsetzung von euren Projekten, wie auch im Konkurs Jonk Fuerscher. Im Heimat wünsche ich euch von meiner Seite aus viel Spaß und bon Courage.
Our next participant is Charlotte Krämer, and she will talk to you about her outlook on spaceflight. Stay tuned for her spacey project.
Hi, my name is Charlotte Kramer, and today I will be presenting to you my paper titled Notes on Spaceflight. So in this presentation, I hope to give you a brief synopsis of the paper as a whole, starting from its introduction to an analysis of its conclusions. So let's start at the start, my research question. My research question is, what is the relationship between the periapsis length and the change in velocity required to escape a celestial body's gravitational field by a rocket when using the Oberth effect? So this paper explores the effects of gravity on low orbital delta V maneuvers, namely how the distance from a celestial body impacts the amount of delta V needed to reach escape velocity. The paper's findings are logically sound, coming to the conclusion that deeper falls into gravity wells will allow for less delta V needed to escape. So I will start by introducing to you the key variables. The periapsis of an elliptical orbit is defined as the point which is closest to the surface of the celestial body it is orbiting about. It is also the point at which the rocket has a highest velocity, as is shown by Kepler's laws of planetary motion. When speaking of a change in velocity, or delta V, this paper is referencing delta V maneuvers, or burns, during which a rocket accelerates propellant out its exhaust, producing thrust. So from the beginning, I hypothesized that there would be a positive correlation between the length of the periapsis and the amount of delta V needed to reach escape velocity by a rocket when using the Oberth effect. So at this point, you're probably wondering, what is the Oberth effect? That's a really good question. The Oberth effect is a rocketry phenomenon relating to delta V maneuvers, which was first suggested by Hermann Oberth, a German scientist and the namesake of the effect, in his 1929 paper titled Ways to Spaceflight, hence my paper's name, Notes on Spaceflight. So here we have some of the calculations first done by Hermann Oberth, showing that the specific kinetic energy of a rocket increases at higher initial velocities, meaning that more kinetic energy is gained for the same amount of delta V at higher initial velocities. We can now begin deriving the specific relationship between the two variables. So to do this, I first had to define escape velocity. I decided to integrate the force of gravity from the periapsis distance to infinity to find the work done by the rocket needing to escape. Equating this subsequently to the kinetic energy needed to escape, a function of escape velocity, I was able to rearrange to solve for the escape velocity. However, that was not all. I then had to take into account the effect of the Oberth effect. So to do this, I used two principles of physics. First, the conservation of angular and specific momentum. As both are conserved in an elliptical orbit, I was able to equate the velocity at one point in the elliptical orbit, the apoapsis, to the velocity at another point in the elliptical orbit, namely the periapsis. I then used the conservation of total energy to rearrange this equation to solve for the velocity at the periapsis. After this, it was a very simple trick of finding the difference between the velocity at the periapsis and the escape velocity needed to escape at that point. So therefore, delta V can be defined as the equation above. When graphing these findings using MATLAB, we can indeed see a positive correlation between the two variables, as I hypothesized. However, to ensure that there was merit to my theoretical findings and to all of the math that you saw before, I had to do an experiment. As I can obviously not launch rockets into orbit yet, it's a little difficult right now, I decided to use a rocketry simulator. So there are a lot more steps, but I simplified it into two. So starting from an elliptical orbit, a periapsis length is reached using a retrograde burn. Note that this periapsis must be above the atmospheric limit. Once at the periapsis, a prograde burn is performed until escape velocity is reached, as is shown by the rocketry simulator. The results are then recorded and graphed. So when graphing the results against the theoretically derived relationship, a very, very high correlation between the two is found, with over 50% of the experimental data going through the theoretically derived trend line, and the rest not being far off. This does bode well for the paper as a whole and gives the results significant merit. However, there are severe limitations. Mass changes were not taken into account, and rockets lose significant mass while accelerating propellant out of their exhaust, which wasn't at all accounted for. Furthermore, the simulator was done on an incredibly small scale, in fact, 1/10 of the size of our solar system, so perhaps the experimental results aren't realistically applicable at larger scales. Nevertheless, the conclusions remain absolute, with a theoretical relationship found and experimental results which strongly reflect it. It can be said with a degree of certainty that this is a relationship between delta V and periapsis length. Following this paper, I would like to do some further research. First, investigating changes in mass, so taking into account the significant changes in mass that rockets undergo. Secondly, investigating at larger scales, so therefore using a proper rocketry simulator and perhaps more trials to give the experimental results more merit. And lastly, by finding specific fuel consumption and efficiency gains using the Oberth effect. I think the Oberth effect has a lot of potential for the future of sustainable long-term spaceflight, which will be a problem and a challenge for my generation, I'm sure. So that is it. Thank you so much for listening. Yeah.
It is Alina Liedke's turn to talk more about her and her motivation in science, culture, and research.
Yeah, thank you for joining us here. This is not the first time that you participate in the contest. What did you work on last time?
Last time, I think it was about 3 years ago, I worked with another classmate of mine on, robots and coding them to be useful for disabled people so that they could maneuver around the house and acquire things from different places of the house. And then I think the year after, I worked with 2 other classmates on rainwater in different areas of Luxembourg. So I think we focused on Bel Air, where I live, and then Wolfendange and Mensdorf. And then we tested for specific ions in the water to see whether they were healthy or whether the water was clean in different parts. And we hypothesized that because Bel Air is near the city, there would be more ions, whereas Wolfendange or Mensdorf, where it's more towards the countryside where the air was cleaner.
Those are really, really different projects. It's love for science, isn't it?
Yeah, exactly. I want to go into STEM, so I focus on a lot of different areas and see which one I'm more keen on.
Which one are you more keen on at the moment?
So far, the most recent one, the one I did today. But I think environmentalism is also very important. And then also technology, but not so keen.
There was a lot of people are talking again about nuclear energy at the moment, and we see a lot of developments and debates and public debates. What's your take on at the moment?
Well, I think it's got its pros and cons, definitely, but I think it's very crucial for us to at least take into consideration nuclear energy before we go fully into 100% renewables. I think we'll need to take into consideration nuclear energy and then slowly diminish the use of coal, natural gases, and the non-renewables. And then maybe from there we could eliminate nuclear energy, but we can't do it. I don't think we can do it as of right now.
I believe it's a really clever take because basically you're analyzing and you're providing data for people to take decisions, and we need that for the debate. So yeah.
What are some of the things that you learned about thorium and thorium power plants that you found surprising?
I actually quite found interesting the idea that thorium is fertile, and yet when it's put in contact with another fissile free material, it can actually undergo nuclear fission, whereas some isotopes just don't undergo nuclear fission at all. So I found that quite interesting about thorium.
If thorium has so much potential to be used to create energy, do you know anything about why it hasn't been used before?
I think it just hasn't been talked about much. And again, as I mentioned in my presentation, there's a lack of research and development. And no one wants to increase that incentive because I think they're all right with using uranium as of right now. But until we go 100% renewable, then maybe thorium could be a possibility.
A lot of people are talking at the moment about asteroid, for instance, or fusion. And do you think it leaves a place for things like thorium in there?
Yeah, I think so.
Yes. Okay.
Cool. Well, so as someone who has participated, who is participating for the third time now, how does this year's contest compare to previous years? Like your experience this time compared to previous experience?
I think it's always been a great experience, especially for a young scientist. I think it's definitely motivated me to go into science, maybe in university. But also everyone is so kind and open. It's been great. But the first time I participated, I don't think I had to do a presentation like in front of everyone. And then the year after, it was all online, so I didn't have to do like a presentation on stage either. So this year is a bit different for me. But I think it was still very nice. The jury were very nice.
Okay, yeah. How did you personally prepare for the presentation?
So I made the presentation quite early, and then I just revised it and then timed it. And I was too long at first, so I had to cut down a bit, and then I had to keep cutting, and then until I found the right time. But I just kept practicing until everything was in my mind and I knew everything.
Were you more nervous for the presentation or for the discussion, for the questions from the jury afterwards?
I think it was the questions for the jury, like in case they catch me off guard or something. But they were still very nice about it. Even if I didn't know how to answer something, they were still very nice.
Did they give you any ideas for further research?
Yes, actually, I think I'll do more research into different power plant types, because I just focused on the light water reactors. But there are several different other ones that I could focus on, but that'll take a while.
So it means that you're coming back next year with a similar project?
Maybe.
That would be good.
Yeah.
Well, or a completely different one, considering the track record.
Yes.
No, cool. Would you have a last word of encouragement to other participants?
I think you don't have to worry about it. Everyone's really nice here. And for those who are planning to do it but aren't sure, I think you should definitely go for it. It's a great opportunity and you don't lose anything. It's just great for you to further your knowledge and your interest in STEM and science.
Cool. Everyone is a winner here.
Yeah.
Lena, thank you very much for your time and good luck for the rest of the contest, especially Sunday.
Thank you.
Thank you.
We are now welcoming on stage our 18th project of the day, which is called Universe in Our Head by Sonia Grudnichkaya. In her project, Sonia reflects on the concepts of consciousness and awareness of our human existence. The floor is yours, Sonia.
Hello, my name is Sonia, and today I'm going to be talking about the consciousness and our brain. So that's the brain out there. I hope it's all familiar. And to this project, I'm not going to be even going into chemical, biological sides of the brain. It's vast, it's amazing. But shortly, what is the brain for me? It's a miraculous machine. It's the basis of thought, memory, action, everything. All the essential things that humans do. However, there's a side in our head which is beyond any physical matter, any material understanding. And that's our consciousness. I heard that phrase a couple of times. I'm conscious, therefore I'm me. Sounds logical, but are you really? Okay, do this for me for a second. Close your eyes. Concentrate on your breathing. Breathe in, breathe out. Breathe in, breathe out. You're probably not aware of blood falling down your vessels, of hairs growing on your body, probably you're blinking with your eyelids closed. Oh, you lost the breathing. That's the true statement. I'm not conscious. I'm not me. But therefore, I am human. We humans seemingly cannot understand and fully process what we are doing at the moment. But think about the potential that humans can achieve by simply understanding what we're doing in the moment. But there come the numbers. here. In this project, I did not just compare mind to universe just like that, for fun. No. I thought about the similarities in numbers that those two represent. We live on our planet, the Earth, which is approximately 3 multiplied by 10 to the power of 60, whatever, of the universe. And that's what we can be conscious of. That number is really small. Just pathetically small. Devastating. Then there is the Milky Way galaxy, which is the consciousness that people get on the rarest occasions. Savant syndrome, whatever. This number is still not even remotely close to 1%. And then comes that 99.99999%, the rest of the universe. The consciousness. Seemingly what we will never be conscious of. But again, what if? Many scientists across the centuries have developed rehab programs. Bahirita with the famous stroke recovery. Rehabbing deaf, blind people. What if there was a device that could have connected all those rehabs to train the muscles, the organs, the neurons, to combine the understanding in processing of all the things we're doing. Now my last point. Why did I go so global? Why did I compare the universe and the brain? I don't know. When I was doing this project, I was brainstorming, analyzing, and that's just the sending point for me. I'm trying to find a concept of some sort of artificial intelligence. Because artificial intelligence, 2 words, artificial and intelligence. Our intelligence is a massive combination of experience, knowledge, and consciousness. So what if, artificially, we could improve it by simply starting from ourselves? I could work on that. Thank you.
Now, let's go back to Charlotte Kramer to learn more about her vision in science and why she was motivated to participate in this year's contest.
Okay, such a fascinating topic. Thank you for coming here. Can you tell us a bit more about what inspired you to delve into that project, basically?
Yeah, so I have been interested in physics for a while, and for me, it was always this idea of, more. Like, we had just Europe, and then we had boats, and we had Europe and America, and then we have planes, and now, I go to Florida every single summer, and this idea of we make something new, and then there's more. And then I think a couple of years ago, I was in the middle of nowhere, and I looked up at the sky, and I saw space, and there's so much more. So I started reading, Stephen Hawking's A Brief History of Time and all of these books on theoretical physics and space exploration and stuff. And I had this moment of realization, that's what I want to do. I want to bring, us a little bit closer to space. So at school, I was reading something and I came across the Oberth effect. And it was talking about how to promote sort of long-term spaceflight and get us, further and further away from our planet and closer to, the reaches of outer space. So I did some research and I found that there wasn't an awful lot on the topic, or at least not an awful lot that I could understand. So I thought, that's what I'll do. I'll try to, show the maths behind the physics, behind the system. I will explain to people like me, or even, to university students, how that works, and I'll find a relationship between these two super important things.
Okay, we see that there are huge developments at the moment, like for space flights, and they are developing new technology, trying to push rockets by lasers, for example, and it's really developing. it means that when you're going to leave university, you're going to be at the heart of like probably the next space flight to Mars. How do you feel about that?
Really good, really good. So I'm about to go off to university, and every single day in the news I read about something that Luxembourg has done for space, or I met an alumni last year or something who's working at a space company in Luxembourg right now, and he was saying, you know, every single day I see a new challenge. And when I graduated from Luxembourg, I thought, I'm never coming back here. And now all of a sudden we see so much space, even in little old Luxembourg. I mean, who knows what's out there? It'll be, yeah, I'm super excited.
Do you have any particular field that particularly interests you? Like you mentioned, like your early interest, but like where would you see yourself in 10 years, for example, ideally?
In 10 years.
On Mars?
Fingers crossed. I wouldn't say no. If they invite me to Mars, for sure.
Okay.
I think for a while I want to stay on Earth. Maybe talk about launching mechanisms and how we can sort of best sustain long-term flight. In the end, I think moving humans off Earth is going to be a big thing. And it's something that I'm looking forward to. I think we're going to be facing all of these different challenges, not even just in the realm of physics and maths, but in, you know, psychology and biology, and how do we pick up a species and move it to a different planet. So I'm super excited for the new space age, and you're right, we're going to be seeing so many different things every single day.
Yeah. What challenges did you come across for this project?
I think finding resources was probably the hardest. A lot of the stuff is, you know, really niche research papers that aren't super applicable outside. And when I wrote the project, I still hadn't done an awful lot of research on the specific physics of orbital mechanics. So for me, I was reading books and teaching myself really basic principles to do this fairly complex topic. So yeah, I think starting up the project and then also being able to sort of compare the results quite accurately. So like I said in my presentation, I can't launch anything into space. So I really had this sort of like idea of how do I make an experiment out of this? Like, how do I do that? So eventually I found a rocketry simulator, but even then it was too small and I wasn't happy with it. But I think it worked out okay in the end.
You should totally connect with the kid earlier who actually made rockets in his garden.
Yeah. To keep building them and so on.
Yeah.
Did you get in touch? Did you, in the things that you read and so on, did you, like with the names that you found, did you get in touch with any of the experts?
Personally, no. But I have been able to reach out through LinkedIn, especially to a lot of heads in industry, and you know, I've spoken to them about my project, and I've had them even look at it, which was really, really exciting. Sort of being able to share my passion with someone that's equally passionate. It was jarring for me because all of my classmates look at it and they're like, "You're crazy." Yeah.
We really can feel your enthusiasm at least. Yeah. Really, it's.
And which bit was more nerve-wracking? Speaking to those people who were doing the talk, doing your talk just now, or talking to the jury?
I think doing my presentation was probably the most nerve-wracking for me. I just had an exam fairly recently, so I walked into the presentation still like thinking about my exam and stuff. But yeah, I think the presentation was jarring, and then being able to talk to the jury, I sort of felt that like, you know, enthusiasm for space that I think everyone at the moment has. It's weird to see it. Everyone's excited for space. So, yeah.
Well, many thanks for communicating this enthusiasm to us, at least. Yeah.
Do you have any last words of encouragement to other participants in the contest this year, or anyone who might want to participate in the future?
Go for it, I think. Definitely. When I heard all of this stuff, like, oh, you have to make a presentation and then do this and then do that, I thought really, oh no, what have I done? But being able to be here and talk to everyone and sort of present the stuff that I love and the stuff that I want to do as a young person and have my voice heard, I think that's so, so powerful. So just do it. Yeah, go for it.
Because it's like important to precise that you have a high degree of freedom in the choice of your topic. And
yeah. You can do whatever you want, really. You can even do rocket science.
Cool. Thank you very much for your time and all the best for Sunday, which is another hurdle. Well, not a hurdle, but another bit of the contest.
Everyone's a winner.
Yeah. Thank you.
Thank you.
Thank you.
Next, we would like to welcome Daniil Murzikaev on stage with his project called Theory of Inevitability of Democratic States. Daniil's work examines different political structures and especially the advantages of democracies. Let's see what he found out.
Good afternoon, fellow listeners, the jury, everyone who's listening to me right here, right now on this amazing day. And actually, to be precise, a democratic state, the state of Luxembourg. I will be presenting a project that's slightly different to many projects presented here today, possibly, because it's a proposition of an explanatory theory that explains many politology and sociology related global factors and emergencies. The theory, again, before I introduce it, I want all of us to, for a moment, be directly submerged into the modern political context at which I'm presenting my theory. Unfortunately, for the whole of Europe, potentially, there is a relatively large-scale war going on right now in the Eastern Europe between Ukraine and Russia that invades it. And you might wonder why I'm introducing it before presenting my theory. Simply because that war, later on, would provide a very good illustration to my theory itself. How? You'll know it by the end of the presentation when my theory would be presented. And the theory, as we all know, is the theory of inevitability, attention to democratic states. So how exactly was my theory constructed? How did I construct it? And how did I come to the conclusion that democratic states are inevitable in history? To understand that, everyone has to comprehend my model. The model is that in every society, in every state, even in the most democratic states possible, like Luxembourg, or Norway, or Sweden, there are constantly pro-democratic, obviously, and pro-authoritarian ideas. They're constantly there. They're never eliminated. Sometimes they're supported, actually often, by certain political parties. That makes these sort of ideologies a lot more visible. And in my theory, in my model, these two ideologies are in a constant struggle between each other. And each one of them prevails as a result of failure of the other, as it happened in many countries of Western Europe. As you can see on the picture, there is a certain cycle here. To explain the way it works, we have to look at the way institutions, political institutions, I'm not talking about economic institutions yet, have evolved throughout history. For example, in Europe, Western Europe, democratization was relatively successful. But that democratization, it does not constantly port more and more democracies in every single case, because we've seen downfalls and rises of democracies throughout history. For example, the city-state of Athens or the Roman Republic, later replaced by the feudal systems all around Europe. So we can agree that democratization is a cyclic process. It repeats itself and it rotates. But that's not what my theory states. My theory states that democratic states, funny enough, the way I said it, are inevitable. So how can we derive that conclusion from the cycles we have? And well, first of all, to illustrate the way I would present it, is that all of these cycles, and I do not deny them, I have never denied them, they're too obvious to deny, existent. They do, however, form a slightly, barely visible sense towards democratization. One may ask, how and what way? And that's exactly what I'm going to explain. But to understand that, we firstly need to understand the advantages democratic states have over relative autocracies, less democratic states. Firstly, efficiency for economic development. Of course, this subject is a constant subject for debates, quite still, but I'd say that democracies do have many advantages in terms of development in comparison to autocracies, relative autocracies. Because democracies concentrate political power on wide spectrums of the population one way or the other than simply a narrow group, they allow more rational decisions, and proven, taken, at least in theory, by the government. And that actually provides high advantages in development. Of course, this is often not very clear because states can, of course, undeniably develop under authoritarian regimes too. It's undeniable. But at the same time, well, first of all, economic development isn't simply growth, the way we want to look at it, because states can economically, the economy can grow under authoritarianism too. But talking about development, for even in the modern statistics, there are certain factors at which very democratic states, such as the European Union in general, and the United States, prevail. Many less democratic systems, such as the same country of Russia, and it's their adaptability to new changes, and for example, green politics. We can agree that there is a large gap between how much the European Union have done to green politics in comparison to countries like China or Russia. That is a clear gap in development at the same time and proves my theory to some extent. Then there is also another factor to prove the sense of the cycles. There is an enormous structural variety of democracies in the world. As I've mentioned, every state, even the most authoritarian one, have some democratic features. For example, a parliament. Many modern systems have parliaments, but the system itself may not necessarily work fully as a democracy, may not be totally liberal. So many states claim to be a democracy, as illustrated on this map. And in comparison to the next map, on the relatively small proportion of the states are actually recognized as electoral democracies by the Freedom House. By analyzing democratic structures, there is an enormous variety of them. Every democratic structure in each state differs from another one way or the other. But in contrast, authoritarian structures tend to identically concentrate sovereign power on very often a narrow group. And that is a very clear sign of how innovative the idea of democracy actually is. Because democracy is nothing else but a political innovation for stable economic growth. At the same time, we can look at another advantageous features democracies can obtain, which actually strengthens them against authoritarianism. This includes federalism, forming federations, and bicameralism, similar structures. It's also created an enormous variety of them. none of them are exactly identical to the other. And that again proves the enormous innovative effect of democracy. Speaking of innovations, democracy itself, because it allows people from a wider spectrum of the population to participate in decision making, it at the same time is an innovation generator. Political innovations too. That's how we get such an enormous variety of democracies. Whereas in less democratic systems, relative autocracies, the only true political innovation that can emerge is the one to destroy and potentially democratize the system. On my slide, I've compared authoritarianist systems with sort of monopolies, because we can compare authoritarian systems with monopolies in the market and monopolistic market, because we can all agree that in a monopolistic market, unless the monopoly is contestable, there are almost no innovations present because there is simply no need. In contrast, democratic systems, in terms of innovation, can easily be compared to a well-functional, organized, healthy, competitive market. That's my economical comparison. At the same time, there are another two pieces of evidence I would like to introduce that would underline the existence of a democratic sense. One of them being statistics. These are statistics created by the Freedom House. They truly show us the evolution towards democracies and cycles of democracy in the last 200 years. And before I finish presenting the sources, it was truly Freedom House, and the graph was obtained from Polity Data Series number 4. Before I conclude, there's another very strong point, very strong argument I would like to present, is that development itself, because states economically develop, is never static. It goes into recessions and growths. And since democracy, as it's obvious, is evoked at a particular stage of development and allows development to be longer lasting, therefore the only way democratization would never have been possible is a situation when there would not be any development. And that is impossible, and it clearly proves pro-democratic sense. Before I conclude, coming back to my first introduction at the beginning, a war between Russia and Ukraine, that war created by Russia is simply nothing more but a resistance towards democratization and repetition of the cycle. Its turn towards democratization, which would eventually happen. Finally, I say, may democracy prevail. Thank you very much.
Now, let's have a quick chat with Sonia Grudnichkaya to know more about her and her innovative ideas.
Sonia, thank you for being here with us. Is this the first time that you take part in the contest?
Yeah, this is my first time taking part in this contest, and I'm super excited to come back.
Okay. To come back next time. So you're already planning to develop the project that you talked about today, or a different one?
Yes, I will most likely develop the project because, as I said, I would like to develop some concept about the technology which will help make people more conscious and aware of themselves.
Yeah. How did this project come about?
I was always interested in neuroscience and the brain, and it was just like fascinating me all the time. I was thinking, what can this machine do, like more? And then when I was thinking about it a lot, and I found out about this non-material part of our mind, which is the consciousness. And I started comparing it to the universe because, you know, we don't know a lot about universe and we don't understand a lot about our consciousness. So that's, I think, how it developed, more or less. Yeah.
How did you go about finding out more, so developing your ideas?
Mm-hmm. I read a lot. I read a lot of books, of articles, of science fiction even sometimes, because it helps develop an idea, a genuine image of whatever. Yeah, I was reading a lot, and many of my science teachers were cooperating with me and helping me reach my goals and find the most information that I could. Yeah.
You picked a really, really interesting topic, and that's so broad in terms of like you can touch philosophy, ethics, biology, everything. What's your favorite part of all that?
My favorite part, I'm in between biology and psychology.
Okay.
Because of course it's really psychological, because humans don't really think about, oh, what am I doing? You know, if you're walking in the street, you're drinking coffee. You're not thinking about your hair growing or your nails cracking or whatever.
Mm-hmm.
I mean, so I think, yeah, psychology, philosophy.
Okay, and do you, what's more important for you is like to be able to develop your brain like the way it is, or like what's your take on transhumanism, for example, or?
My main goal, I think, now is to, first of all, develop not only my brain. Humanity needs to evolve further, because, as one wise man once said, if we're not evolving, we're going back.
Mm-hmm.
So we need to evolve eventually, and to speed up that process, I think that technology is going to help.
Okay.
I think so.
Where does your passion for science in general come from? What do you say?
From my childhood, I would say. I loved doing experiments, you know, with like explosions. First it was chemistry, then I started buying models of brain, models of different body organs, and then I started eventually reading, and my aunt was actually a professor at a university in my town, and she opened science doors for me by like telling me stuff and educating me. Yeah.
You study the brain quite closely for that project, and in general, do you know any fun fact that you think nobody knows about the brain?
Fun facts. I mean, off the top of my head, I don't really.
What surprised you the most, maybe? You were talking about the percentage of what we use, for example, or...
Okay, so the percentage of what we use is biologically in our brain is... People say that it's around 20%, but I think it's even less. And one of the facts that I most like about the brain is that in only the brain, there is more than, like, there's a few trillion neurons. And the fact that no one has really captured neurons, because it's like a speedy thing, really speedy thing, it's just fascinating, because if you think about it, it's just like a net of little tiny sparks in our brain. Yeah, so that's really interesting.
Okay. Then thank you for coming. We really appreciate, and let's really hope that you're coming back next year.
Yeah, I
with
will.
more development on that project.
I definitely will. Thank you.
Thank you.
Thank you.
Please welcome on stage our second to last participant of the day, Ekaterina Karageorgiadi, who is going to present a project called Color, How it Affects Emotion and Its Associations.
Hello, thank you. I hope you're all doing very well. So today I will present to you my study about how color affects our emotions and how we associate it. So I want to talk to you a little bit about my idea first. So I grew up in an artistical background. I always had a lot of artistical freedom. And one of the things that I noticed a lot of other kids didn't have was the option to choose colors in your room. So my mom, as an artist, she always let me pick the colors that I wanted my walls to be. And she would never let me pick warm color palettes like red, orange, yellow, because she would always tell me that I would never be relaxed in my room if I had those colors. So I wanted to investigate a little bit more on that and see why do we like certain colors and why do we dislike certain colors? Why is my favorite color purple and why do I dislike so much the color orange? Does it have to do with the way I associate it with, the way it makes me feel? So I looked into it. I noticed one day when I was in my brother's room, I was playing with a Rubik's Cube and I noticed this. My brother has LEDs, and under a purple light, the colors of a Rubik's Cube changed completely, while under a yellow light, the colors stayed as the colors we know. So I thought, okay, color, there must be something there. So under yellow light, we see the colors normally, but under purple light, we don't. There must be, color must not be a real concept that way. It depends on three things, actually. Under the light that it's under, we have a yellow sun, so we see everything under a yellow perspective. If we had a red sun, everything would be different. Then second, the way light reflects on certain surfaces. And third, how we, personally, our eyes and how our brain processes each color. That's why there's a lot of times where you have a shade and some of you might think, oh, this is dark blue, while some others might think, oh, this is black. So the psychology of color, the exact definition would be color psychology is a study of the effect that colors have on the moods, behaviors, and feelings of people. And for example, when you have a red color palette, you immediately think of danger. You think of intensity. You might think love, you might think passion. It's alarming. While blue, it's a cool color. For some, it might be a very sad feeling. It might be very calming, comforting. And I wanted to look more into that. So I had three hypotheses along my study. The first one, colors associated with places, objects, with positive objects will be liked more. There will be a higher liking, higher scores of points on a liking scale out of 5 stars. So our opinion of colors is heavily associated on, it's heavily based on the way we associate them. For example, red you associate sometimes with blood, so you will not like it that much. And third, most participants will prefer cool colors from warm palettes due to their lower intensity. So I conducted a study for that. I decided to send a questionnaire out and let people tell me what they think of each color. I was very happy. I got around 150 responses, and analyzing the data was a very big difficulty. I got a lot of qualitative data that I had to turn into quantitative data. And I had 40 questions, and I asked individually each color. I asked people to tell me one association and one emotion they associate the color with. So an object, a place, a person, and an emotion. And this is what I found. I created a little a picture, little chart to show what each color and the 4 basic or most used emotions associated with. I got this idea, it has been done before, but I still wanted to check and I still wanted to create my own chart. And I did find pretty different results from what I found in the internet and from books. So I was pretty surprised. There was not much variety into what people thought, but it's still pretty, I was still pretty happy with my results. And what I also found was that the most liked colors were cool color palette colors. So blue, green, and purple. And it ended up, my hypotheses were wrong. Two of my 3 hypotheses were wrong. It turns out it does not matter what you think about a color emotionally or what you associate it with, because the highest reason for a person to like a color was that they like to see it around them and that it's calm and soothing. In this case, yes, cool color palettes, they were calm and soothing, but it has to do more with the environment rather than our personal, psychological, emotional connection. And it was the same with the most hated colors. The most hated color came out to be yellow, orange, and brown, the 3rd place. And the reasons were also the same. They didn't like to see it around them, and it didn't represent them. So more of a personality rather than an emotion or an association. So I also did an intensity scale to see what people think is more intense and correlated with my results of most liked and most favored and most disliked. And warm color palettes had an intensity scale and rating out of 8, 6.25, and cool color palettes 4.8 out of 8. So my conclusions, blue, the most liked color, yellow, the least liked color. I expected to see such trends, but again, my hypotheses were proved wrong. And then I thought, how can I use my results? Color psychology is mostly used in marketing. Now, it's something that triggers our emotions without us realizing. So yes, it's mostly used in marketing. So I hope that somebody might be able to use my results when it comes to that, or in their advantage, as in paint your room in a calm color palette, not a warm one. And thank you for listening to me.
Let's hear from Daniel Murzikaev on how he came up with his theory and the motivation for his research.
Daniel, thank you for being here with us. How did it come about that you did this project?
Well, certainly it's very clear that contemporary events, certain events that are happening right now, political events and events that were happening when I started doing this project, because they're always there, there's always something happening. That was probably my biggest inspiration on analysis of the events around me. That's would probably be my answer. Also, I want to say that I'm very interested in those kind of topics in general since several years ago, actually. Initially, I wanted my presentation to be a bit more economics related, but it turns out sort of more sociology related than I planned. And that's why
you did more research and so on, and you found more you found that there was a lot of information that would feed into the topic. The focus of your project was more on the German political system to start off with. How did that change?
Well, simply, I've used Germany, to be more precise, at the time when Germany was still divided by the Eastern and Western Germany, GDR and FRG. FRG is still existent, luckily. I personally used it. The only reason I've used it is because I found it to be one of the most perfect examples of illustration to my theory, because that I've chosen those two states simply for comparison of performance of different kinds of states and different kinds of systems. And the thing is, very often it's very hard to actually compare them because the circumstances are different. That's a bunch of research experience coming from me. And I found the German example the most suitable examples for me and the most comfortable. But as you may have noticed, I've changed my illustration example. I've changed my state. The only reason I did that is because my new example is a lot fresher than the example of Germany. And at the time when I actually wrote when I was writing the project paper, that was before my new example has appeared. So the example of Germany was pretty much the best example I could find from an illustration. But because of the political circumstances, not that I support any sort of violence, I just use them as an illustration. That would actually give more comprehensible volume that you can feel immediately to my presentation. That's what I thought, and that's how I replaced my examples.
Could you maybe give us some more example of other countries that would fit for the model?
For the model, for example, on North and South Korea. So a contemporary example, I could also use this. The thing is, the example with the Ukrainian war is something that has appeared very, very recently. It's very fresh. As I've already said, I wanted to add volume to my presentation to place it into this contemporary word. But the example with Korea could also well work. At the same time, it would also be a bit more difficult, not just with Korea examples, but with say comparison in general, because unfortunately, it's very often states that I want to emphasize, in contrast to democratic states, that there's often a lack of reliable data about them. For example, the same North Korea. I mean, people do launch investigations about those countries. At the same time, data is quite limited. Even about countries like that same country of Russia, statistics are still deformed. And again, that was also the reason for the example I chose at first, because there were actually some pretty reliable data available about the states I was contrasting, about the East Germany. I found quite a lot about it. And the contemporary examples, since it's happening, example actually, the example with the war happening in Ukraine right now, it's happening right now, and actually lots of data about it are quite available and clear. Again, another reason for why I chosen it.
Yeah, thank you very much for your time here, and all the best for what comes next, especially on Sunday, where you're presenting a poster. Is that right? Yeah.
Yeah. I will be presenting, obviously. I mean, I've signed up for this.
Then very welcome. Yeah. Thank you for everything, and see you soon.
I would like to actually thank you more.
And now, for our last participants of the day, we have Zaina Faye Nyang, Nora Kanini, and Joy Ozadebawem Daniel. They will be presenting their project called Is Prevention Better Than Cure?, which seeks to answer this question through a medical, historical, and environmental perspective.
Hello, my name is Nora.
And my name is Zaina.
And my name is Joy.
And today we'll be debating the question, is prevention better than cure?
Prevention is better than cure is often a phrase often attributed to the Dutch philosopher Erasmus. And today we're going to see just how valid this statement truly is and through 3 fields of study.
Medicine,
history,
and environment.
First, we'll start with medicine. To understand the question, we need to look at what is cure. Sorry. Well, once again, we will be starting with medicine. And to understand the question, we will need to look at what cure is. Well, cure is a substance that stops an illness or condition. And some of you may be wondering, what's the difference between treatment and cure? Well, the difference between these two is that some diseases can be stopped while others can't. And those that can't need treatment to keep them under control. And some benefits of cure are that it gives hope to people with medical issues, and it restores health to a person. And some problems with cure is that some diseases tend to return, and also it's not accessible to everyone because not everyone has health insurance. Nevertheless, these problems can be solved by reducing costs and improving insurance coverage. What is prevention? Well, prevention in the field of medicine is the action taken to decrease the chances of getting a disease or condition. Because no one likes to deal with medical problems in the future, so prevention helps them achieve this. And it does this using 4 methods: primordial prevention, primary prevention, secondary prevention, and tertiary prevention. What is the importance of cure? Well, the importance of cure is that it aims to discover health issues before they become real problems. And it's also very helpful for people with chronic diseases. It helps them live a normal life. The problem with prevention is that not everyone has the pleasure or luxury of living a preventive health, lifestyle. And also not everyone has access to preventive healthcare because of lack of resources, for example, in undeveloped countries. Some benefits of prevention is that it increases life expectancy, and it's very important for the future sustainability of the society, and it also helps avoid high medical bills. Now let's look at an example.
Which is the Black Death in the 14th century Europe. A little bit of background information. The Black Death was an epidemic of the bubonic plague caused by a bacterium called Yersinia pestis. It was transmitted through fleas which infected black rats and then humans in its 3 different versions. The plague claimed over 20 to 25 million lives in its 5-year span, and this lack of population resulted in devastating results for society. Labor efficiency plummeted, and agriculture came to a complete stop, resulting in the economy becoming poorer. Governmental activities ceased, and towns were left deserted as their populations fled elsewhere. And of course, there were the remaining survivors who had to deal with the trauma and had to find the cure. In talks of prevention, critics suggest that the plague could have possibly been prevented with rodent control and proper hygiene, as they were both lacking at those times. However, one must consider that technology was not as advanced as it is today, with the bacterium only being identified centuries later, which poses the question of prevention even being a possibility in certain situations. One can also ask whether prevention would have been beneficial, because there were some benefits in the situation. The survivors of the plague claimed the possessions of the deceased, which created a social change, as the poor were now rich. Landlords had to decrease their rents to keep their tenants, and workers started demanding higher pay for their work, which raised the minimum wage. There were also many changes in social society as language, manners, and fashion. Now, considering the main statement, in history it becomes a bit complicated, because if we prevent one event in history from happening, there is a chance that we are also preventing the subsequent events and the benefits from occurring as well.
And lastly, I will talk about how prevention would have been so effective in the field of environment. It is no secret that the Earth has been suffering as a result of pure neglect over centuries. Excessive use of nefarious utilities have caused various environmental issues. Some of the methods include deforestation, which is the removal of trees to allow something other than forest. Rising sea levels, which is caused by the melting of the icebergs. Global temperature risings would have been rising unusually rapidly over the centuries, and as well as air pollution. Moving on, it's safe to say that I think there's a problem with this. Yes. Okay. Moving on, it's safe to say that we would be in a different state if we acted earlier. In 1886, a Swedish chemist, Svante Arrhenius, discovered the connection between the greenhouse effect as well as the climate change. And even more recently, in the 70s, it's been proven that it was caused by the said effects. However, the prediction predescended to controversial topic and weren't heeded. Now is the time to do something about it. Today, now that we are aware of what a possible future would look like if things don't change, we can now take measures to alleviate the grave situations. While we can't prevent consequences from occurring, it's still possible to act now in a way that will guarantee a better future. And so, speaking of changing our ways, And so, speaking of changing our ways, here's a few things we can do to prevent future calamities from happening. First, we can reduce our global footprint by monitoring CO2 emissions. We can also use and implement some geoengineering tactics to help counteract the effects of global warming. And as always, with unity there is strength. And as always, with unity there is strength. One small action goes a long way if everyone does it.
So, is prevention better than cure? With the help of our biology teacher, we managed to hold a small survey asking some students whether they think prevention is better than cure. With 44 participants, 21 said yes, while 23 said no.
We collected some opinions from outsiders, and if you are interested, please do not hesitate to ask after the presentation. Thank you.
In conclusion, with this analysis, we can say that yes, prevention is better than cure.
Prevention also saves time, money, and effort in the long run. As well as, and though the cure has its pros, like learning from mistakes, it's too risky and too costly.
Prevention is not possible in every situation, but it's encouraged in every situation that it can take place. I want to say special thanks to our teachers and students, and also from our family members and friends, and also Mrs. Lara. She was very helpful. Thank you. Yeah, that's the end of it. Thank you.
Well, before we come to the end of this wonderful scientific journey, we will first hear out Ekaterina Karageorgiadi on her project, and right after that, Zeina Faye-Niang, Nora Canini, Joy Asedebawem, Daniel will get their turn to tell us a bit more about themselves and their ideas.
Thank you for being with us now. Where did the inspiration for your project come from?
My passion for art. As I mentioned, I've grew up in a really cultural family. My parents always let me experiment with music, art, and it felt like the right project to go with when I was introduced to the Young Scientist contest.
And was that at school where you heard about the contest, or?
Yes, I was informed about it in school.
Okay.
But there is there is a love for art definitely here. But what brings you to the actual scientific aspect of it? How did that come from?
Well, I started this year psychology in my school, and I really love it. And I thought, why not research it? I wanted also to look into more biological projects, but I don't know. It was the first thing that came in my mind, and it felt like the right thing to go with as well.
Okay.
Well then, what emotion linked to color was the most surprising for you to find out about?
That's a good one. I would say brown. The most surprising association was royalty, would you say? Luxury, brown. I did not expect that at all. I thought that people would go with something more dirty in a way. But I was really surprised that people did not think like that at all.
Okay, do you have any explanation for that?
I don't, actually. Brown now is frequently used in homes, in buildings around us, and I think people are more exposed to that than like dirt or land or earth, and I think that's the reason.
The subject you're studying is like heavily demanded by marketers and like companies doing consultings and things. So it can have actually a lot of applications. What's your take on it? Where would you like to take your research to?
I would like to take my research more to the personal rather than the marketing.
Okay.
So I would rather prefer my research to be used in personal psychology. So if you could use it as a person, if it could somehow help you improve your psychology throughout the day, if by, for example, having a bright color in your room would help you be more happy in your daily life, I'd rather research more into that than the marketing side of it.
Mm-hmm.
And one thing that I wish that I could use my data and my research in was hospitals. I get that they use the color white frequently, and because it represents cleanness, it's purity, but I think it does not help people recover.
It's also sterile, or well, sterile and so on. So what color would be good for patients to see?
Blue and green, and pastel shades of colors, more cool colors like purple. And I think that would be more interesting than white, but also calming enough and clean and sterile enough to help balance both requests.
We see a growing interest in your gestures, like when you're talking about hospital and colors. Does it mean that you're coming back next year with a project on colors and hospitals?
Hopefully.
That would be very nice.
I don't know where I want to take it next year, but I want to definitely look into it more and research into it.
And come back to the contest?
Yes.
Very good.
Then what encouraging words do you have for other participants this year or for future participants?
I think the most important thing is to come forward. Don't be scared, and put the effort and the time to investigate and search into some of your ideas. And you have to start, you always have to start somewhere. And this is a beautiful contest. And yeah, don't be shy to come forward. Don't be scared to work a bit more. That's my.
Which was the most fun part for you?
Getting the responses from the people, having actual people respond to you. It's a whole different feeling, because yes, you can be researching an entire day in a lab or in the internet, but nothing. That was the most fun part. Seeing people put a little bit into your research. And it was fun reading some people had really funny responses, and I had to say I really enjoyed some of that, even though it was a pain, because analyzing 150 responses was not the.
Through that.
Cool. Well, thank you very much for your time with us.
Thank you.
And good luck for Sunday. Especially.
Thank you. I'll need it probably.
There we are. It's over. You've done it. How was it?
It was nerve-wracking.
Yeah, it really
nerve-wracking.
was.
Yeah.
And though you've been dancing on stage.
I was just nervous because I had to shake off the,
Shake off the stress.
Yeah.
It off, I guess.
Yeah.
But before starting, just wanted to say that we liked your dynamic actually. It was
Thanks.
nice to see.
Thank you.
So which bit was more nerve-wracking? The presentation itself or the chat with the jury afterwards?
The presentation itself. Yeah.
Especially with the clicker.
Yeah. Oh, the click off.
What happened?
You would just click and it would just, I don't know, skip a few slides. You had to look back and
then you weren't paying attention, so they would have to tell you that.
Say no, please.
The good thing is like you were well prepared, and then like you could bounce on it, so it was okay. And the jury questions then were alright.
Yeah, they were right.
That was actually
Usually
nice.
it's complete opposite. People say, yeah, the presentation was okay, and then the jury, it was nerve-wracking.
I know.
They made it really comfortable.
Yeah.
Okay. Very good.
Yeah, sure.
Well done, well done, well done. How long did the three of you know each other?
Wow. Me and her for like almost 6 years. Yeah,
Us probably 3-4 years now.
Yeah.
3 years.
Yeah. How did this project come about?
Well, at first we all had because we had to discuss a topic, and so we all brought different topics to the table, and she discovered this question, and at first we had to think about it, because we were like, oh, is that something we really want? And then we discovered that in each of our separate lives, we've all kind of had that question come up, because we all have different experiences in which that question has come up. For example, for me, I'm a patient of territory prevention because I have a chronic disease. So this question was really always in my mind, could I have prevented this, and from here, where do I go from, because there's no cure. So for me, I really found it interesting, and that's why I did recommend that we do it.
Yeah. There was one slide where you said that some people said that no answered the question no. So they thought that cure was better than prevention. What do you think made them? Why would they think that?
Honestly, we asked, the students that we asked are younger students. And I think the reason why they think that, the cure is better, because one, the answer is already there. And they think that maybe having to find it, you'll learn a lesson, something valuable. Yeah, I think that's why.
Yeah. Also because of COVID, like one of the judges said, because we asked the question during COVID times, and they said everyone would really just want to get this over with and just find the cure, because it's a whole process. We had the vaccines, we had the mask, we had the quarantine, and all of this is to prevent it from becoming worse. But if we ask them now, everyone just wants to cure it and move on with their life. So that's what a lot of people said.
Yeah. And so it's a unique situation and so on.
Yeah.
Okay. Yeah. Interesting. Really good.
On a more personal side, how was it to work the three of you on one same project?
It was easy, it was smooth sailing, because we all get along.
Yeah, we all get along.
Yeah.
It's normal everyday thing for us.
Yeah.
How did you separate the tasks, for example?
So
you were the boss?
No. She kind of brought all of this together, but I'd say Joy took more of the literature part because she likes writing and reading, and Nora is more of a presentation, wants control of how the structure is, and I just like doing videos.
Yeah. So
which sounds already good.
Yeah. No, she did the paper, the excellent paper. She did the amazing, entertaining video, and I just did the presentation. So it was all equally distributed. No one did more than anyone else.
Yeah.
Okay.
Yeah.
Was it very time-consuming?
Not really, because we are very good at managing our time, and we also have a lot of free periods.
Yeah.
So
that's
okay. Yeah. So, but it is a matter of organisation, being organised. Yeah. Cool.
Yeah.
Cool.
I heard a will to come back next year with a new project.
Yes.
Yeah.
Yeah, we have to see, because next year's our last year.
Yeah, we have the
best. So we'll see what happens. We start thinking.
They're thinking about it.
Because your project is on point, it's very actual, and so we might need you.
Do you think you will continue in science?
Yeah. Yes, definitely.
Definitely.
Yeah.
Very nice. We need more women in science. And what part of the project did you find most fascinating?
For me, it was it's the way that everything came together. You know, it was something unrealistic. You know, it's like a very independent thing. You know, because it's not a school thing. So you just really felt like, you know, it doesn't matter. You're not gonna get graded on. It's your own thing. It's an independent work. You know, it depends on you. So I felt very in control.
I agree.
Yeah, so.
Like in the beginning, it was really just an idea, but then we started working on it and we started coming together. You know, we finished a document, made the video, and we were sitting there thinking like, wow, we're really doing this.
Really. Also, to film the video, we had to go to a farm.
That was the fun part.
Yeah, we went to a farm.
That sounds like you had a lot of fun. So it's like a lot of work, a lot of fun, and then like a big presentation, and suddenly the pressure releases.
Yeah, that is very true.
What words of encouragement do you have to other contestants or people thinking about taking part in the contest?
It's okay. Honestly, things happen, but it's as long as your attitude is okay. Like, even after I came down and the judges were so nice and everything, I was like, yeah, it was really intense, but everyone is so nice and it's okay. It's really okay. There's nothing to worry about.
Yeah, just go for it. You have absolutely nothing to lose.
Exactly. And always have fun.
Yeah.
Very good to hear that.
Cool. Well done. Thank you very much.
Thank you very much.
Good luck for Sunday. And maybe see you again another year.
Thank you. Thank you. Thank you. Bye. Have a nice day.
Oh, we've got.
We have now arrived at the end of the first day of our competition.
Thank you to everyone at home for watching, and please join us tomorrow from 9 a.m. for more exciting projects.
Do remember that the stands of our participants will be accessible on March 20th as of 12 p.m. So feel free to come, take a look, and ask the participants any and all questions about their projects.
See you tomorrow.
Bye.